Hello guys, welcome to my channel and let us have a look at this question paper. This is the Maths paper 2 from November 2024. It was written by the matrix as the final examination. So what I'm going to do here guys is to try and give you an overview of what you are working towards in the coming finals of next year. This is to highlight some important areas and learning points for the new matriculants who would be joining the class from grade 11. And of course, this can serve as some sort of a revision for those who would be willing to upgrade should they not get a satisfactory mark. All right, so what is maths exactly? I'd like to start there. What are we doing in maths? How can we summarize maths in such a way that when we perform our actions, they are more informed than just random thoughts and, collisions, so to speak. Maths is often misunderstood. Many say maths is difficult. Some say it's for the gifted. Some say you need to learn it in your home language. Idea is none of that matters actually. You just have to look at maths however you want to look at it. Because mathematical language on its own is a little bit different from the common languages that we use, including the English language in which we learn maths. So if you look at the study that was conducted recently, where the grade 5s from many countries, I don't know how many, 50 something, and then South Africa was one of those countries. Look at what happened. Singaporeans dominated everybody. But is Singapore a country that speaks primarily English? Not necessarily. But they understand it. So what is their secret? Mainly, it's starting their kids early. The Asians almost always do that. Even at 4, a kid is made capable of doing important things. So they don't grow up randomly and carelessly like we do ours. Here we allow kids to not talk properly. We allow them to play more than they learn, and yet their brains are like sponges at that time. They learn pretty much everything that comes in contact with them. And that's the best time to introduce things gradually, so that by the time they can make sense of most of things, they can start creating things. That's the idea. It's not the language. So let's cut the nonsense. We don't need to learn maths in our languages because the countries that primarily speak English, like the England, the USA, they didn't make number 1 or number 2. In fact, they were not even fighting for those spots in that study. They are somewhere there in the top, but they're not exactly in the number 1 or number 2 spot. So this already highlights the fact that it's not about learning maths in English, but it's all about learning maths whichever means necessary or in whatever way that has been made common in your country. In ours, it's in English, and we can appreciate that most of the English that is involved here is pretty basic English, so all we need is just comprehension, that's all. Alright guys, let's cut to the chase. Now, I would summarize maths into some actions or procedures that we perform. First of all, these procedures and actions are based on a few things, like knowing numbers. This could be the real number system, where we talk about natural numbers, whole numbers, rational numbers, irrational numbers. We can extend this to even numbers, odd numbers, etc. Okay? We need to appreciate this. So every textbook has these. And the reason for this is not for decoration purposes, but for proper understanding of what's coming. Technically, this is knowledge from previous grades. Okay? We need to keep that in mind. Now, the second thing is we need to know properties. The key here is properties of shapes. Now, when you talk of shapes, this could be parabolas, could be hyperbolas, it could be cubic functions, it could be, trigonometric functions. Most of the functions I would classify under shapes. And then geometric figures as well. We could be talking about triangles mainly and quadrilaterals. We can add circles and many other things, cylinders and so forth. All right, so that is also very important. And then of course we get to what I call the three-step approach to solutions. Again, this speaks to solutions. So what do we do when we solve a mathematical problem? Step one involves what we call BODMAS. Overseas you would see this sometimes termed PEMDAS. So BODMAS directly says brackets first. So in any mathematical expression, we first deal with brackets, then ordinals, meaning exponential expressions, not just exponents. That would be careless, but it's exponential expressions, and we call these ordinals. Now, PEMDAS in the US and elsewhere, P means parentheses, which is brackets. E is for exponential expressions, but carelessly called exponents, and that's not correct, okay? And obviously, we move on to division, then multiplication, addition, and subtraction. And the standard order of operations is such that we do the reverse operation. If we have, for example, a bracket is more like division. So how do we deal with that? We multiply out. That's simply that. And then, of course, ordinals, if we have some number raised to a particular exponent, then to undo that, we take the root of whatever the order is that exponent. And then we deal with division. If we have division, we do multiplication. If we've got multiplication, we can do division. And these are essentially interchangeable. Addition and subtraction, again, we start with addition, then subtraction. Again, these two may be interchangeable as well. But when this is used, applied, we can talk of the BO as the brackets off. In the lower grades we often talk about. This would be reduction formulae. We know that in maths we can remove brackets by applying reduction formulae. At the same time, we can also use cofunctions or corratios. Same thing if we are looking at this applied. AS could simply be speaking about special angles. Now guys, this forms 90%, up to 90% of our solutions. This is what I call the final common pathway because it's arithmetic. Okay, that's the common final pathway, and we need to appreciate that. Again, it builds up from the lower grades. Now step 2 and step 3 are what I call keys, because once we set this up, we either unlock a way of finally solving to the answer using step 1. Now here we factorize. But what is factorization? It's nothing but division and multiplication looked at simultaneously. Because when we factorize, we literally divide by something, and that which we divide by we keep, and whatever remains when we divide it we also keep, and this is made to be a product of some sort. Now there's 3 ways we can do factorization. We can take out the highest common factor between terms in a polynomial. We can also do difference of 2 squares or any polynomial, the common one being a quadratic trinomial. But again, all of that is based on long division, but we've got some shorthand techniques like inspection or the bracket method or even the so-called synthetic divisions to try and factorize these much more quickly and efficiently without wasting time with long division. But in those that we cannot do that, we simply need to do long division. And this is the essence of algebra, because mostly in algebra we will be doing a lot of factorizations. Now algebra is nothing but arithmetic where numbers are linked with variables. That's essentially that. And then doing this may unlock step 1 to continue. And we've got step 3. Sometimes step 2 may go into step 3 first and then back, but these can interchange or swing. Step 3 is what we could use as a law. Think of exponential laws, logarithmic laws, or even theorems for that matter. Okay, we could be using an identity, as in trigonometry. We could be using a formula, take, for example, a quadratic formula, or in differential calculus when we want the gradient formula, we use the first principles. It could easily be just pure logic. Sometimes a lot of things are just logically connected. So once we unlock these locks or keys, once we use these keys to unlock something, we could use step 3 to unlock step 2, or step 2 to then proceed with step 3 and then step 1. But these two steps almost always lead to the final common pathway to our solutions. And then just something extra. It is important to note that most multi-step higher order questions or higher grade questions, they involve simultaneous equations. This is pretty simple in question 1 of the first paper, but elsewhere we then apply this, especially for the multi-step questions where we calculate something above and we use whatever results from it in the next step until we get to the answer. So that is a series of simultaneous equations. Then of course when you get to higher learning, you would find that a series of multiple, maybe 3 or more simultaneous equations, we can actually do the so-called determinant by essentially looking at that matrix. Okay, that's what we call linear algebra. So there's a whole lot of things, guys, that you can look at nicely and sort this out. And of course linear algebra is based on concurrency. When 3 or more lines intersect at a common point, then we can actually formulate a system of simultaneous equations that way by using the coefficients mainly. Anyway, guys, this is just me trying to give you something to think about. So as we solve these problems, we will almost always be looking at this. And then of course, guys, this is very important as well, because this is how we solve mathematical problems. Of course, influenced by the pre-knowledge that we need to possess and some techniques and tricks that come along with experience as well as we practice more. Now let's go to the next piece. Now, approaching the question paper, we have to pay attention to instructions. They are very important. Now, we are told here that the question paper consists of 11 questions. We need to check, because in the final, you may find that your question paper is not complete. So be very careful, or there's something wrong. So I've got question 1. You can see all adds up to the total. Question 2, again, it goes all the way to the total, so that suggests it's complete at least. Question 3, adding up to the total. Question 4, adding up to a total of 20. Question 5 with a total of 12. Question 6 with a total of 18. Question 7 with a total of 11. Question 8 with a total of 9. So these are all complete, at least we can see that. Question 9 with a total of 6. Question 10 with that total of 15 marks. And then the last question with 20 marks. So we can appreciate that this is complete. In fact, we can look at the information sheet. Do we have it? Yes. Here we even have, the answer book, but I'm not going to use it. It's just too little. I don't know why they give you this, guys. You should be given a booklet, like an exercise booklet. You write where you want and for as much as you want. Can't be limited, because honestly, this impacts on how you deliver your answers. Now, the second one says answer all questions. Guys, this is a very important instruction, but we answer all of these in the special answer book, which is bad. This, for me, I don't like. They should stop this. All they need to do is to go back to the old way. It works. Given an exercise booklet where you can write as much as you need to and even add pages. Then they give you a sort of like a booklet as well with those diagrams specifically designed for those questions where these diagrams are important or just extra. That you can annotate, because it will submit along with the answer book. And then of course, this is very important. Clearly show all calculations. This is for calculation based questions. We can show a diagram, a graph, etc. Now the most important is this etc. Meaning, if you used a formula, please show us. If you used a reasoning from Euclidean geometry, please show us. Any law, logic whatsoever, If you use something else, please show us so that we don't think you copied. Okay, it's very important. Now this is all the things that we have used in determining our answers. Now it says answers only will not necessarily be awarded full marks. Obviously, if we write an answer only, it is only applicable, or should we say it's acceptable, in a 2 or less question. So when the question is 2 marks or less, an answer only is appropriate. But it is not necessarily going to give us full marks when the question has greater than 2 marks. Okay? So for a question that has more than 2 marks, you can't just write an answer only. But a question that is 2 marks or less, an answer only is acceptable. So this is something to ponder on. Now, other things is that of rounding off, which is very important as well, because it also determines how we score the marks. So I will flag these ones with asterisks, because those are the main instructions you really want to focus on. Okay, we round off to 2 decimal places only in this one. No more, no less. So understand the language used in directing how much decimals must you have in your answers, okay? Unless otherwise stated, of course. Then diagrams are not necessarily drawn to scale. That's something to really keep in mind, so that as much as we're not going to say, for example, we need to do a distance on a line segment, then we've got the coordinates at the ends of that line segment. We can't just measure that with a ruler. We have to perform some calculations. But the manner in which that line is drawn, if it is on the Cartesian plane, its position must reflect the answers on the coordinates, okay? Very important. Now the information sheet for formulae is given. Now remember, some formulae may not feature there. So if you feel you're going to forget these, before you even start answering any questions, write any extra formulae that you can remember on that information sheet, so that under pressure and stress, anxiety and whatever you're going to experience during this paper, you know that at least if you use a formula that is not there, you already wrote it down. And these are formulae you would want to kind of, revise before you get into the exam room. Then we write neatly and legibly, not necessarily nicely. Some people have very nice writings or beautiful writings, but all it means is that there has to be, it has to be something readable and something that the marker can follow nicely, okay? All right, guys, so we're going to start with question 1. Let's handle question 1. Easy. Now, question 1 is a grade 12 question. Of course, not necessarily always, but this one in particular, it's a grade 12 question. So this is bivariate data, meaning 2 variables. So we've got x and y. And we know in maths in general, whenever we cast something on the Cartesian plane, the dependent is the x-axis. Sorry, the independent is the x-axis and the dependent is the y-axis. So this is already labeled, but if it is not labeled, to decide which one is which, it is important to read the statements carefully. It says, at the beginning of a season, the coach of a junior boys rugby team, okay, that's the name, recorded the weight in kilograms. Again, pay attention to how this is written. Of 15, again, totals are important, 15 players in his team, and the number of push-ups that each player was able to do in 1 minute. Again, this is very important. These push-ups were done in 1 minute. Okay, these are key areas to make sure you highlight and you understand. Now, can we see, guys, think about it. Could the number of push-ups tell us directly or more accurately about the weight? Maybe they can give us an idea, but not so much. But the weight can determine the number of push-ups you can do, because if you are heavy, it becomes more difficult to do a lot more push-ups. But if you are sort of like intermediate weight, then you can do a greater number of push-ups because it means you're stronger, flexible, and perhaps fit. But if you're also very weak, meaning your weight is too little, you won't have enough energy to do a lot of push-ups. So be very careful. But we can see clearly weight can actually influence the number of push-ups a person can perform in 1 minute. And therefore we can see that the independent variable is what seems to drive the second one rather than the other. Although if we have a clear relationship between these two, we can use this one to actually work back the weight. But if we were to decide which one is more dominant in independence, it would be the weight against the number of push-ups. So very important to read statements carefully and also analyze exactly where they would go. Categorize them as well. Now the data is represented in the table and scatter plot. So this is another way of representing or summarizing data. So we can summarize data on the table or on the scatter plot, because then we can make inferences, can even allow us to perform analysis on these kinds of information. Now the least squares regression line. So this is another way of analyzing data. So this is what we use for data analysis of bivariate data to see the correlation between those two usually. Okay, for data is drawn. Now we can see that. Now if you look at this trend, 34, 32, okay, 27, 30, 38, can you see quite a number of push-ups, depending on their fitness, of course. 27, quite a number. 44, okay, all right. But we can see that the bigger weights, like 40, maybe 57, 55, can you see the biggish weights? Although there's still a 44 that does better, but we can see that the biggish weights, expectedly so, we do less push-ups in them. That makes sense a bit. And we can see the intermediate weights, if we can call them that, we're doing the most number of push-ups in a way. Okay, so that is great. So this already suggests for us that most of the data is suggesting that, well, the bigger the weight, the lesser the number of push-ups that can be done, which makes logical sense. And then the intermediate weight is almost performing, around average and above average, okay, so to speak, and on average maybe, or what we would expect to be essentially our yardstick. And yeah, that's effectively what we can see. And as we look at the scatter plot, this is what we will qualify as an outlier, because we can see this one is too distant from our least squares regression line, while others are populated heavily around and on this line. Okay, good. This is very nice. This is very easy. So if one says, is this identify an outlier, this would be the one. Okay, so this is what we can essentially see on the scatter plot. And there's not a lot for us to do. So we just move on and start answering questions. 1.1 says, determine the equation of the least squares regression line for the data. Now this is calculator work. So maybe before we start answering 1.1, I need to map some steps. First steps, we go to mode. This is on the calculator, of course. We go to mode. Then from mode, we select stats. Okay. From statistics, we were going to select this A plus BX. It's written like that in most calculators. And then as we select that, a table like this shows up where we've got X and Y. And then all we need to do is to fill in the tables. But now how do we fill in? We press the number and then an equal sign. This is how we fill in the table. It's number and then an equal sign. And then of course we use arrows. We use arrows to navigate. Okay, up and down. So if we want to go up, we use a downward arrow. We want to move to the other one, we move the arrow to the left. We want to move back, the arrow to the right, up and down. So that's what we do. Okay, so once we finish doing that, we press the AC button. What does this AC button do? It literally helps us to store data. This one stores the data so that we can analyze it however we choose to. This is the first thing that we do. Now the next step that we need to do, we then go to the shift button or the shift key, then we press number 1, button 1. At the top you will see it's written stat. So when we press the shift key and that number 1, we unlock the statistic function. Then this, we choose the regression, it's written reg, and then from the regression we can choose A, we can choose B, we can choose R, the correlation coefficient. Okay, this is mainly what we're going to do, but also we can do more. We can find the mean of the X variables, we can find the mean of the Y variables, we can find the standard deviation in terms of the X variable, can find the standard deviation in terms of the Y variable, etc. These are not commonly questions that are asked, but these are things to consider as we work our magic. Okay, so this is basically, guys, me trying to teach you this so that you can try some questions even before you study this section. Okay, I'm sure some of you already have grade 12 question papers and maybe some textbooks as well. It would be helpful to start working on those. So guys, let me input my data onto the table like I just said and then start working. Alright guys, so my data is ready for use and stored. So to answer this question we need A, so we just do this. Now this procedure, guys, is repetitive. You repeat for each parameter. For each variable, maybe for each parameter, I don't know. Yeah, let's just say repeat each time. Repeat each time. But there are calculators online, but now you're not allowed to use your cell phones in the exam. Even if you're going to say you're going to use the scientific calculator app on your phone. But those ones are very good in that they do all these things. They display it on the screen. You choose what you want instead of doing multiple things. All right, so let's have a look. A, so we go shift, press 1, we press regression number 5, and then we choose A. And then A here comes as 46 to 2 decimal places. B, we repeat shift 1, regression, and then we choose B. So this is minus 0.59. Okay, great stuff. So therefore our y-accent is 39.46 minus 0.59x. This is how we do this one. Very easy. So this is a mark, that is a mark, and putting them together. Again, use the correct notation. As much as you could use this first and that next, but try to use the notation that is being taught at times to avoid unnecessary problems. Now we need to write down the correlation coefficient. So we need to write down the correlation coefficient. So this is easy. We're looking for R. So we go and repeat the process. Shift number 1, regression, then we choose R, Then R is basically minus 0, 797. Now to 2 decimal places, this becomes 80. Please don't ignore this 0. It's important. Remember, the answer said where we need to round off, we must do 2 decimal places. If you do 1 decimal place, you lose this mark, okay? So don't lose marks unnecessarily, guys. It's not necessary to lose those marks. Now it says the coach uses the least squares regression line to set the target for the minimum number of push-ups by each team member according to their weight. Okay, so this is the minimum target according to a person's weight, meaning for this person to be doing a bare minimum, he has to fall on that line. These guys must be on this line or above this line. These guys were already above the line and on the line. They are fine. They're doing the minimum already from the beginning. All right, now it says predict. So once we predict, we use our equation. Of course, if the prediction is within the domain of these values, then we know this is interpolation, which would be an accurate prediction. But if the prediction is outside this domain, that's called an extrapolation. That's innately an inaccurate prediction, so to speak. All right. Now, we need to predict the number of push-ups that a member of the team who weighs 29 kgs. Can you see they didn't say 29 grams? So be very careful of the notation here. This is kgs. And we saw that everything is in kgs. So if not, please change it accordingly. Should do to meet the target. So this is easy. Y accent 39,46 minus 0,59 into 29. So here we just quickly do the substitution. Say y implies that our answer is equal to, so we can do this easily, 39,46 minus 0,59 into 29. So we are getting 22,35. Remember, number of push-ups is an element of natural numbers. We can't have a 0,5 push-up. It's either we count it in or we disregard. So we need to round off to the nearest. So we can easily say, therefore, the member should do approximately, now this is basically just 22 push-ups, to meet the minimum target. Right, so that's good. So always try to answer in full. It is much more palatable to show that we are approximating things. Obviously, guys, this substitution is key, and essentially the final answer gives us 2 marks. But even if you leave it like that, I don't think you would be punished, but try to show that you actually understand what you are doing. So 1.4 says write down the mean number of push-ups for the given data. Can you see the given data or data? Now if we're saying number of push-ups, we're talking about the y. So basically it means we want y bar. That's the mean. Now we go to the calculator and we do this. Okay, maybe let me show what we're going to do. On our calculator, we go on our shift key. we're going to choose option 1 or button number 1. This time, what we're going to do, shift number 1. Now we're going to choose VAR. This is the variance. We know the variance gives us the standard deviation and the mean. Okay, so we choose VAR, which is option 4 in my calculator, but it can be anywhere in yours. And now what we're going to choose is Y bar and then press an equal sign. It gives us an answer. So this is the procedure. So you don't need to start all over again. Know how to use your calculator. So we can say Y bar is going to be, I look for that, which is option 5 on my calculator. This is 18,33 push-ups. Okay guys, so that is essentially what we have, and obviously what we're going to do, this is basically approximately 18 push-ups. Of course, remember push-ups, element of natural numbers, so we don't need to do other things here. So obviously guys, the question said write down, so we need to think about it. So this whole thing you don't show, it's in your rough work. Come up with the answer. Okay, so just write the answer only and leave the rest alone. Okay, so that's it. So easy 1 mark, we move on. Okay, next question is 1.5. 1.5 says the players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. How does the increase in the number of push-ups influence the standard deviation? Okay, now remember the standard deviation, guys, is the distance of each data point about the mean. All right, so if everything increases, even the mean will increase by 5 push-ups, and that would mean all those distances of the individual data points would remain the same about the mean. So we can just say here, no effect. Okay, this increase will have no effect whatsoever. So again, very important to know these things. And if you don't know what a standard deviation is and what it represents, obviously this becomes a bit challenging for you. You will want to add this 5. You can still do it manually or use the calculator. You just take these data points, you add each one to it. Sorry, on the push-up, you add 5 more, and then we can process that thing and see what happens. We'll see that we get the same standard deviation. All right, good. 1.6, the end of this question says, at the beginning of the season, the coach used the least squares regression line as the minimum target for a player to aim for. Okay, now it says determine the maximum possible increase, okay, in the number of push-ups that a team member must obtain to reach. Remember, this is a matter of a must, because if we don't reach the target, that member doesn't make the team. Okay, so it's a matter of a must. And remember, we're saying maximum possible increase. Now an increase, it means we can see that these guys above this least squares regression line are already above target. The ones that are on the line, they exactly meet the target, but the guys below this line don't meet the target. So these are the guys we need to push up. But now the greatest distance away from this is this one. So our target is to get to the line at least. So this means we need to adjust this. And the difference between these two is exactly the question that answers this particular question, because all these ones can move just a little, but we need all of these members to meet the target. Think of this as a vertical shift of this graph, because obviously if we increase each one by this, it will shift this graph to somewhere over there, but it means these guys would fall, this guy would fall here, meaning would meet the initial target, and the rest would be history. Okay, great. So this is again a question that demands a bit of understanding and logic. Remember, this would have been an outlier, but can you see it tells us by how much each guy should at least increase to actually fall above this average. But again, since this guy seemed to be a bit of an outlier, we can say that would be the maximum increase, because if each one gives this and nothing more, they'll be well above the target, and this guy will fall right on target, and that's good. Okay, so that's easy, guys. We're going to use our prediction again, so we can just simply say y bar, or maybe we can say okay, let me see. We can say y bar is going to be 39.46 minus 0.59 into, now this time we use this weight, 40, because we need to correct it so that it falls on the target. This implies that our y bar is going to be 39.46 minus 0.59 into 40, and we get 15.86. Again, remember, this is the number of push-ups, and we can see this falls exactly on the line, so we round off to the nearest. So this is approximately, now remember this is more than 5, so we round up, so this is going to be 16 push-ups. But now that was not the question. The question is, what would be the maximum possible increase? We can say therefore the maximum possible increase is going to be equal to, we take this value 16, we minus the original there. What was this? This is 1, 2, 3, 4, 5, and we see that, so that's 6. So we minus 6, which is going to be just 10 push-ups. Okay, so this is what we need to do there. All right. Of course, this is what makes sense, should be done, because if we're saying each member must get to the target, that means by how much must we shift this? So that vertical shift is good because it shifts everything up there and everyone meets what was the previous target, because we can look at that as the minimum. All right, guys, that's very easy. Of course, certainly this was important to substitute that and to set up this equation, in my opinion. It's just 2 marks. Okay, this answer is more important than the rest. So I don't know, guys, you do what you have to do there. The mark could be here. Okay, the mark could also be here, because we know we had to use this. Since this is nothing but interpolation, we know this is accurate, so we can accept this. But since we got a mark above, I doubt if we could get a mark for another substitution into a similar formula. Maybe we can say, okay, we want to debate that and say maybe it could be in the memo, but perhaps this one is more important. All right, okay. Now, guys, that sums up the 10 marks of this question. Okay, this is a grade 12 question, so try practicing as many as you can find. And of course, you will struggle at first, but once this is taught in class and you do more exercises, homeworks, and more question papers, this will become second nature. Okay, this is something you can answer in 10 minutes, truly. Let's look at question 2. Now question 2, this is a grade 11 question. So this means revise your grade 11. Remember, this is grouped data. When we do a cumulative frequency graph for grouped data, we get an ogive like this. Alright, so the cumulative frequency graph and ogive. Again, know how to pronounce and call this correctly. This is from the French. They call it an ogive. Ogive. So the G is sort of like pronounced softly. It's not ogive. They say ogive. 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 So obviously the equivalent to that kind of calling, you sort of like pronounce it like a J. So ogive. You can't say ogive. Ogive. Okay? Remember these kind of things. Again, guys, make a habit of improving yourself and transforming yourself. Don't be, too common. Be a little bit special sometimes. It will make you more and more useful. Okay, shows the time taken in minutes. So the way in which we are taking this time is important for 60 employees. Now totals, guys, is something to pay attention to travel to work each morning. Okay, great. So this ogive represents the time taken in minutes for 60 employees to travel to work each morning. Okay, obviously, guys, the last plot always correlates with the totals. Remember that. So the total here must always correlate with the last plot. All right. So this last plot, the cumulative frequency always correlates with the total. Okay, maybe let's do this. Those two must correlate. Nice. Now, what is the other thing? We need to know how to anchor this. Now, where we anchored, this is the lower limit of the first class. And of course, where we plot, we always plot the upper limits. So this is one class. This is the second class, third class, fourth class, fifth, sixth, seventh class. So this is 1, 2, 3, 4, 5, 6, 7 classes. So this is essentially what this means. Now we can see the classes have intervals of 20 minutes. Nice. The other thing that we need to sort up is the gradients, because the gradients on the ogive can tell us about, what we call the model class, or the class that contains the greatest number of frequencies. Now that is fairly gentle. This looks steep. That looks a bit steeper. That looks a bit gentler, maybe. Of course, this is not accurate, and then it levels up until it plateaus. Now, remember, the greatest gradient here will tell us about the model class, meaning the class which contains the greatest frequency in the original grouped data. Now, we want to know, where is this model class? So we draw tangents, and then of course a gradient is what we call a rise over run. We can see that the run is intervals of 20 minutes. So the run is the same. So we are more interested in the rise. So if we look at this one here, this one goes there and there. All right, you can see that. And then this one goes from there to there and up there. So we're interested on the y's, or the y-axis. And then this one, because these ones look more or less the same. So this is why we are obsessing over them, because we need to make sure that what we do makes sense. Now we're just taking time to look at this. We know that the run, which is the horizontal movement, is the same, so we don't worry about it. But a gradient is rise over run, meaning the y-axis over the x-axis. So essentially we want to look, how many units is this? Now we can check here. from the bottom to the top. This is 1, 2, 3, 4, 5, and we see 5. So that means the smallest scale here represents just 1 unit. So we can check here how many units is this one now. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so this is 13 units up. What about this one? This one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this one is 16. Okay, it doesn't really show nicely. And then let's look at this one. It's how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's very close. That's why you see they look more or less the same, but they're just close. So can you see this is 15 against 13. Now can you see the biggest rise? If the numerator is bigger, the ratio is bigger. So this gives us the greatest gradient. Okay, so that's good. So this means our modal class is here. This is what would make up the modal class. Now this is the class with the greatest. Can you see most people take an hour and more to get to work? Others are doing less. Those are probably closer. These ones are doing more. They're probably further away. But at least the most people are not so bad. They're not so bad. You can try to drive an hour earlier so that you can get to work nicely. These ones are in trouble. They need to change where they stay. Okay, guys, so this is very good. So you can see there's a whole lot of things you can learn from just processing and analyzing the data that is given. Because sometimes certain graphs look like this is the same gradients. It looks like it's a straight line, and it's not. So a bit more carefulness in our approach is important. So you use a rubber, of course, to do this. Please, guys, do this when doing your practicing. But when in the exam, you should know exactly what you need to do. And the other thing that is important is to skim these questions before you answer them quickly, just to see if you need all of those things so that you don't waste time. But you should be well aware of how to perform those duties if they be required. Anyway, let's have a look. So what do we want? We need to estimate the median time. Now the median time, what we are going to do, we are going to take the total cumulative frequency and we divide it in half. And that lends us to 30. So we take it from 30 and we run to the ogive, okay? Now from the ogive, we can see that the ogive is landing straight down this one. Is landing up straight down that one, and that one we need to figure out. Now if we have 20 here, how many little ticks do we have? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for it to be 20, it means the little tick here represents 2 units. Now this is 60, this is 2, 4, 6, so that would be 66. That becomes the median, which is Q2. So we write it out and say 2.1. We know that Q2, the median, is going to be equal to 66 minutes. Now the manner in which this works, okay? Easy stuff. 1 mark. 2.2, it says estimate the lower quartile. Now the lower quartile is going to be half of the half, okay? Or the lower half. Now 30 divided by 2 gives us 15. So we come up to the 15 one. We intersect the ogive. Now as we intersect, in fact I did not do it. So make sure you get to the ogive nicely. Now as we get to the ogive, we can see this one drops down here. Okay, so this would be our Q1. That's what we want. So lower quartile is going to be equal to, now we said this is 2, so this is 40, 42, 44 minutes. 1 mark, nice. 2.3, it says estimate the interquartile range. So for us to do that, we need Q3. Now Q3 is the half of the upper half, so 60 plus 30 is 90, divided by 2, that's 45. So we go along that line. Okay, this one doesn't want, it's not exactly straight. So let's try to sit on the line as best as we can. And you see, this one drops down nicely in this line, okay? So that is good. So again, can you see this is 80, 82, 84, so that would be Q3. So we can just simply say the IQR is going to be Q3 minus Q1. This, we said this is 80 to 84, so this is 84 minus 44, so this is 40 minutes. Okay, easy stuff, easy stuff. Okay, so this is how many marks? 2 marks. Of course, estimating the Q3 and then the final answer. Easy stuff. No big thing there. No big things. No big things. Next question says, the minimum and maximum times taken for an employee to travel to work are 5 minutes and 20 minutes respectively. Okay. This is minimum and maximum. Now it says on the scaled line in the answer book, draw a box and whisker diagram to indicate the distribution of the data represented in the ogive above. Okay, that's easy. Again, grade 11 stuff. So let's go and find that scale on our answer sheet. Okay guys, so we've got it nicely up there. So we must use a ruler then to do this. So sometimes this thing misbehaves, you know. It likes to do that. So we must use a ruler. This is 5 over here because it's in between 10 and 0, so that should be 5. And then we want to go on and find our maximum, 120. So this is where these ones go. Okay, the next we saw that Q1 is 44. So Q1 is 44. This is just before 45, which could be there. So 44 must be here. Okay, we do that. And then Q2, we've got 66. So this is just after that. So maybe there. Okay, we put a dot over there. And then Q3, we got 84. So this is just before that, maybe there. Okay, that's what we have, guys. So what we need to do now is to draw our thing. Okay, so that one is good. And we'll try to draw this line straight up too. Okay, it's not exactly nice and straight. I don't like it. So it has to be this one. Okay, that's much better. Of course, guys, use your ruler and make sure everything works out nicely. Then we can just join the whiskers. I don't know why it doesn't want to become a straight line. It just wants to do its own thing. Okay, whatever it does, I don't really care. The thing is, it's done. That's what matters right now. Maybe this one is a bit angled. Okay, it looks a bit better. Then of course we need to get rid of some extras here. We need to get rid of some extras. We don't need them. Oh no. Leave it alone. Leave it alone. Leave it alone. So we're getting 2 marks for this. So guys, easy. Not a big deal. Okay, alright, okay. So this is what we do, folks. This is what we do. Now 2.5. We need to answer the question. It says now the company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. Okay, now what percentage of the employees will be allowed to work from home for part of the day? Now obviously guys, all the guys that are going to do this, remember our maximum is up to 120, so it's going to be this 60 up until 120. So those are the guys. I mean 120 correlates with 60, so we just need to take this one up into our ogive and do the things. So we take it from 60, we go to the ogive, and then it takes us straight across over there. So beningafuni izenze straight line mani ngicela kabi. Okay, so that is 25. We saw that this one goes in ones, so this would be 26 over there. So this one will give us the number of people. That difference is going to be the number of people who travel for an hour and more, because this is what it says. So we can just simply say the percentage of people, the percentage of people or employees, maybe let's put it nicely like that, the percentage of employees is going to be 60 minus 26. That is over the total, which is 60 multiplied by 100%, which is going to be what we get. So this is 60 minus 26. That's 34 divided by 60. Get what we get. We multiply by 100. This gives us 56, now 6, 7 to 2 decimal places. And that's it. That's it. So this is good. Now, how many marks? 2 marks. Okay, great. So obviously guys, this numerator is important, and the final answer is a 2 marks there. Not a big deal. And let's finish off this question. 2.6 says employees work 8 hours in a normal working day. Okay, now the manager decided on the following rule for time to work from home. An employee is allowed to work half an hour from home for each time interval of 20 minutes or part thereof, meaning in between that interval, above. Key is this is above an hour taken to travel to work. Okay, so that's a very easy rule to follow. It says now on a certain day, an employee takes 110 minutes to travel to work. So where is 110? So 110 is here. Yeah, but it's too dark. Maybe let's choose something bright. So this is 100. This is now 2, 4, 6, 8, 10 is here. 110 is there. Okay, that is this guy. he is over here. Now 110, we can see how many time intervals is that from an hour. This is 20, 40, 60. So there's 3 because there are 3 of these time intervals. Remember we said for each time interval of 20 minutes. So this would be 1, 2, 3. This is part of it. So we've got this one, and that one. So there's 3 of these. And now we're getting half an hour for each. So this is going to be basically, they calculate the number of minutes. So we can just simply say number of minutes. It's going to be basically 3 times 30, which is going to be equal to 90 minutes. Okay, cool. So this is very good because that's all we needed to do. Half an hour is 30 minutes. Then we multiply that by those 3 little things, because for each one we get half an hour, and that's what we have. Very easy here. So I guess this is very important in the answer. Can you see, not a very complicated question as well. And then we take that total of 10 marks nicely. Alright guys, you can appreciate that grade 11 work is easy, and this is what you've been doing. So please practice it again, because you can see it gives you very fat 10 marks. And you can appreciate, guys, that we answered these 2 questions, the first one and the second one, in a matter of 20 minutes, because by the time we started working on this, it was almost around 30 minutes or so. Don't worry about the explanations. I'm just taking you through it nicely and easily. Okay, now let's move on to question 3. Now this is when the real stuff and the main stuff, the core, is. And here marks can be scored, marks can be lost. Let's approach this question. Now usually this is a question on analytical geometry from grade 11. So again, revise your analytical geometry from grade 11. But at times it may gravitate towards grade 12. So again, you will have been introduced to some of the materials from grade 12 as well. But revise grade 11 work. But here it's usually the combination, mainly grade 11, but some grade 12 material can come in as well. Alright, so let's have a look. We are told in the diagram below, triangle ACD has vertices A. There's no coordinates, so this is a potential question. Nice and easy. And D with coordinates 3 and -9 sorted. C -9 and 0, it's exactly on the x-axis, so this is an x-intercept, where A is a point in the second quadrant. So this is very important. Now you may wonder, why am I being given this? It means this is definitely a potential question. So we need to find a way of answering this. And since this is a second quadrant, it means x must be negative, whereas y must be positive. So we need to find an x value that is negative and a y value that is positive. That is simply suggesting that. Okay. Now B with coordinates -1 and k. Again, we can appreciate that this is a point in the third quadrant. So this means we need to see that k must be a negative number. It can't be positive. Okay? K must be a negative number. That's it. That's it. Now, question is, oh, by the way, this lie on side DC, meaning these points are collinear points. Not a problem. Now what can we do? Well, we can find the gradient of this line because we've got 2 points on this line that are complete. From the gradient, we can use the knowledge of collinear points, meaning between any two, the gradient should be the same. So we can equate the combination of B and C, and maybe C and D, to find the value of K. Or we work out the equation of this line, and from the equation we substitute this point and solve for K. So we've got a plan for that. Again, if needs be, we can find its angle of inclination, but I don't think it's that significant. From the equation, we could easily find the y-intercept. Again, I don't think it's that important. But now this line, we don't have enough information to do anymore, okay? As well as that line, we don't have enough information to do anymore. So this means for us to work out A, we need more info, okay? So we need more info to solve A. We can't solve it with what we have been provided initially from this statement. Now guys, here's what is important with analytical geometry. Now when you're doing the finals, you want to make sure you choose the battles you want to fight, okay? Let's check. Now what can we do with what we have? Calculate the gradient of DC. That is good. We can do it. Determine the equation of DC in that standard format. We can do. Show that K is equal to -6. Can you see it's already negative, which proves our theory, and we can do it by substituting it into the equation. Calculate the length of DC. Again, we've got points on that one. We can do that. Calculate the ratio of DB over DC. Now that we would know the coordinates of B, we can actually do that. If M is a point on AD, now this is a story. If M is a point on AD such that AC is parallel to MB. Now we need to do this construction, so it must be parallel to that. So something like that, maybe not exactly. Okay, that looks a bit better. So we are being told here that we've got M here with coordinates X and Y. And if we are to find out what are they looking like, this one must be plus, this one must be negative, okay? Because this is a point in the 4th quadrant, at least, based on this graph. And we are told that this line has to be parallel to that line. Okay, not a big deal. Now, again, this introduces a topic from grade 12. Can you see? This is where grade 12 comes in, because this sets up what we call the proportionality theorem. So this may help for us to find the ratios of these two sides, okay? But will it help us to find what we need? Not at this point. Okay, so it says calculate the ratio of the area, okay, of triangle MBD, so this one. So basically, guys, we are saying we're looking for this ratio of this triangle and the bigger one, all right? But what is so common about them? They have the same angle here. So if they've got the same angle, remember, ratios and proportion are created by this parallelity using the proportionality theorem. So this will help us to essentially work this out because we've got this in common. And we can work out the ratios of those sides. That would be the same. Cancels out nicely. So this means, yes, we can calculate this question. Can you see? We're just trying to choose battles to fight right now. Now, if it is further given that the gradient of AD, what is that? So the gradient of AD, this is -4. Okay, so this is this gradient right here. So this is -4. Okay, not a problem. And the length of AD is the square root of 612 units. So we can see that we have this length given to us as the square root of 612 units. All right, can you see, guys, we needed extra information. So what can we do with this one? It says calculate the coordinates of A. Can you see? Exactly our point. We needed extra information, and with that we can actually derive simultaneous equations. Okay, and from those simultaneous equations we can solve this problem now. So this is very important. Can you see, guys? You know that these marks are coming in. Of course, this is a higher grade question. This is another higher grade question. You almost always have the hard hitters, and usually the hard hitters will combine some grade 12 work and some higher grade work from grade 11, because this is purely grade 11. But this includes a bit of grade 12. But if you think about it, yeah, I think this one is a grade 12, but this is purely grade 11, but a higher grade question. Okay, now, guys, we can see that, okay, here we can actually bank all the marks if we want. Let's start. 3.1. We need to calculate the gradient of DC, so we know that gradient of DC is going to be y at D minus y at C divided by x at D minus x at C. Now y at D is minus 9 minus 0 divided by 3 minus 9, this is plus 9. So this is 9 over 12. So this is basically minus 3 goes 3 times to 9, goes 4 times to 12. Of course, we can see it's a less steep gradient and it's negative. So we can accept the answer. It makes a bit of sense. So usually substitutions, and the answer gives us the 2 marks. 3.2 says determine the equation of DC in the standard linear format. So line DC as a vector is going to be y equals the gradient, which is minus 3 over 4x plus c. Now we can choose any point. We can say through point D, which is 3 is to minus 9. It is such that minus 9 is equal to minus minus 3/4 into 3 plus c. Therefore, we can appreciate that our c, this is going to be minus 9 over 4. We transpose. Now, this is going to be 9 over 4 minus 9. So we multiply the 4 here, we get 36. So 9 minus 36 is minus 27 divided by 4. Of course, you can use the calculator just to double check that everything is good. Let's see what is 27 over 4, minus 27 over 4. It's 6,75, okay, which is roughly 6,8. And we can appreciate that this point, the y-intercept, we can appreciate that this is the point below that, okay? And we were told this is minus 6. And then it's above that point, so it's good. We can take it in, and then we can say, therefore, y is minus 3 over 4, x minus 27 over 4. And that is our equation for the line DC. So what is important here is substituting this point and getting us the final equation. Very easy, not a complicated question. So 3.3, we need to show that k is minus 6, not a big deal. So we know that essentially, we know that y here is minus 3 over 4, x minus 27 over 4. So with point B, with those coordinates minus 1, and k. It is such that k is equal to minus 3 over 4 into minus 1 plus 27 over 4. All right, okay, all right. Therefore, k is going to be, now basically this becomes positive. So 4 is the same. So 3 minus 27 is going to be minus 24. No, this is 30. Hey, magancane wena man. Wrong calculation. Yay. Be very careful of signs, guys. Interrogate the quality of the answer you get, because I'm surprised now what's going on. So this is positive. So this is 3 minus 27. That's minus 24. Minus 24 divided by 4. That would be minus 6. Okay, easy stuff. Now, look, when the answer is volunteered, sometimes in maths, they almost always provide you some way of proving. Of course, first we need to check the sense of the answer in a way. That was okay, reassuring. But now this answer provides us a way of proving. If we get a minus 6, we've used this equation from that gradient. It already proves that those two are correct. So, what do we get here? 1 mark. So basically it's just a substitution into that point. Easy. So can you see, as we go along, we know that we are doing the right thing. So we can do 3.4 here. 3.4, we need the length of DC. So DC is going to be equal to the square root of x at D minus x at C all squared, y at D minus y at C all squared. So we substitute x at D, this is 3 minus 9 is going to be plus 9 all squared. Y at D is minus 9 minus 0 all squared. So we'll just do this nicely. So we've got the square root of 3 plus 9 squared plus minus 9 squared. This gives us 15 units. Nice and easy. Okay, good. So how many marks? 2 marks. Usually substitutions and answer. Please make sure this is written. And pay attention. If one measurement is suggested that this is 9 meters, just know that when we do a distance, we must write meters or centimeters or whatever that is. At the moment, it's safe to leave it there. So 3.5. We need to find that ratio. So that's easy. dB over dC is going to be equal to, now we can just do the calculation here. So obviously the distance formula, we can just jump in. We've got 2 points on dB. So we can say this x here, which is 3 minus the x there, it's minus 1, is going to be plus 1 all squared plus. Now we can say the y there, it's minus 9 minus the y value there, it's 6, so it's minus 6, which is going to be plus 6 all squared. This is all divided by 15. Okay guys, when you're not confident though, don't do this, it can hurt. So let's do the numerator first, because we might just need that length. So this is 3 plus 1 all squared plus minus 9 plus 6 all squared. It gives us 5 divided by 15. So 5 goes once, goes thrice. So this is a third. A ratio does not have units, so we leave it here. Okay, very easy. Obviously, how many marks here? 2 marks. So probably the mark is finding that distance of dB and the final ratio. Always simplify the ratio whenever that is possible. Okay, so we've got some marks up our sleeve, folks. Now let's have a look at 3.6. Now 3.6 says we have this scenario, and we can see we set it up already. Now we just simply deal with the area rule here. So we can just say area of triangle MBD over area of, okay, all right, okay. There's something that I'm missing. Can't just jump in. Remember, we need to set up the ratio as well on this side. First of all, we can say essentially in triangle, can say ADC. What can we say? We know that essentially DM over, so this is going to be DM over DA. The Democratic Alliance is going to be the same as this ratio right here, which is DB over this whole one, DC. Okay, so what do we know here? The reason here this is proportionality theorem, we state with BM parallel to AC. Okay, good. Remember that property was given to us and we can use it. Now what can we say? This is definitely equal to, what did we get? DB over DC is a third. So this means we can choose a variable for this one. This could be, say, B, and this could be 3B. Annotate once you have an idea, and that is equal to that. But at this point, we don't want to complicate our lives. We just want to use that proportionality. We can say then area of triangle MBD over area of triangle ACD. Now we set up the area rule. This is going to be equal to half. Now the side is DM times DB times the sine of the included angle D divided by the half of, say, DA times DC times the sine of the common angle D. This is area rule. All right, so just simply simplify. Now we can see half and half are the things, and that are the things. So what do we end up with? We end up with DM times DB over DA times DC. Simplifying. What is DM? We chose B there. Into DB. What did we find? Now you see, uncovering that length of DB is important. So this is 5 divided by the DA is nothing but 3B into what is DC? We calculated DC to be 15 units. Now we can easily see that again B is common, right? 5 once, 5 thrice. You see that? So what do we have? At the end, we end up with 1 over 9. 1 over 9. Great. So we can help ourselves there with those marks. Can you see? Very easy. Very easy. So we know that 5 times 9 is 45, right? Which is 3 by 15. And yeah, that's good. It's a ratio. We leave it like that. So what is important here is this statement, because we wouldn't know that it divides like that. And then we needed to find that. I don't know if that is mark worthy. It's not a big deal. And then here, setting up the area rule, I do believe is significant. And essentially the answer is significant. I think the numbers are just, not so much. Not so much. Okay. Easy there. So annotate the diagrams that you are given. Can you see, guys, we are taking these 4 marks nicely. Of course, the marks can be given here if somebody likes. That's not a problem. One can deduct that mark, still okay. It's another area to consider for the marks. Okay, not a big deal. Now let's deal with this last question, 3.7. Maybe let's take it in a new question. In a new page. So 3.7. What do we have? It says, what if it is further given that the gradient of AD is like that and the length is essentially like that, we need the coordinates of A. So obviously, guys, we know that from here we can say the gradient of AD is basically y at D. Now what is y at D is minus 9, isn't it? Minus y at A, that is basically going to be, okay, maybe let's do this. It's going to be y at D minus y at A, just to avoid problems. X at D minus x at A. It helps to just be systematic at times to avoid problems. We're given this is minus 4 equals minus 9 minus y, we just chose y over there, divided by 3 minus x. Okay, so this is over 1. Then we just cross multiply here. So this implies that we have minus 4 times 3. This gives us minus 12. Minus 4 times minus x is plus 4x equals a multiply, that is minus 9 minus y. Now we can take y to the other side and isolate it. So this will transpose to here, minus 4x. Then we've got minus 9 plus 12. That becomes plus 3. Does it make sense? This actually gives us the equation of that line. Literally. Gives us the equation of line DC. But what is key is that we have y. And y is the coordinate there, which is what we are looking for. So obviously, guys, we can call this one equation 1. And then we can say here also, we know that essentially AD is equal to the square root of essentially x at D minus x at A all squared plus y at D minus y at A. This implies we are given that this is the square root of 612 into, substitute, again x at D is 3 minus x all squared into y at D, it's minus 9 minus y all squared. And then of course we know Once we've got square roots, we don't like them. We get rid of them. So that gymnastic is very important. In fact, we could easily have just said AD squared is like that, instead of needing to do this, but it's not a big deal. 612 is going to be 3 minus x all squared plus. Now here we want to quickly substitute. This is going to be minus 9 minus into, what do we see there? Y is 4 minus 4x plus 3. All of this is squared. And then of course here what we did, we just put I'm trying to think, man. I'm trying to think. Maybe I rushed, you see. Sometimes in ngiyapapa. Must see in this systematically. Let's not rush. Although there's no need for what I'm about to do now, just to avoid issues. So this is minus 9 minus y all squared, okay? So we can make this one equation 2. So what do we say? We can just simply say put 1 into 2. Now, what do we get? We end up with 612 equals. So we sort this out. It's going to be 3 minus x all squared plus. This time we do what we did, minus 9 minus into minus 4x plus 3. So please guys be able to use brackets appropriately. This is 612 equals, we FOIL this out, it's going to be 9 minus this is going to be 3, it's going to be minus 6x plus x squared, okay? Plus, now we need to first sort this out nicely, I think, before we start moving. So this is minus 9 plus 4x minus 3 all squared. Be systematic, don't be in a hurry. So we've got 9 minus 6x plus x squared. Now we can sort this out one more time. Minus 9 minus 3, it's minus 12 plus 4x all squared. Systematically, guys, systematically. Way. The politicians are there. So this is 9 minus 6x plus x squared. When we FOIL this out, we get 144. 12 by 4, that's 48. So this is minus 48 by 2. That is 96. 48 times 2, yeah. So this is going to be minus 96x plus 16x squared. Now we need to handle this like a quadratic, because we can see we've got a quadratic here. So we've got x squared and 16x squared. So these add up to 17x squared. The next one are the x terms. So minus 6x minus 96x. So we add 6 to that, we get minus 102x. Now let's see. Now this is 9 plus 144. That gives us 153. We then transpose this, we subtract 612. This gives us minus 459 equal to 0. Now let's check, can this divide 17? Say divided by 17 gives us minus 27. What does that one give us? So 102 divided by 17 gives us 6. So it's going to be minus 6x, and that becomes x squared. This is when we divide by 17. Okay, equal to 0. We can then attempt to factorize. We normally should be able to. Otherwise, it would be a silly one. 27 is 9 and 3. And the difference gives us 6. Okay, bigger number must carry that, the smaller number that. So we can say therefore our x at A going to be minus 3. We disregard that. Why do we know? Remember, we were told that this is the point in the second quadrant. X is negative. That's why we're choosing the negative. We don't want the positive. We can say therefore y at A, we're going to substitute this into our first equation. So this is minus 4 into minus 3 plus 3. Now we can see this is going to be plus 12 plus 3. That's going to be 15. And again, it's positive. Therefore, A is minus 3 is to 15. We can accept the answer. Okay, so guys, can you see this 6 marks is a bit of work? Usually the higher order questions are like that, but do you see simultaneous equations as we highlighted in our summary? So this is usually what we deal with in these questions. So most important here, I would say substitutions in this equation, very important. And maybe here just this one is key, that is 3 marks, and then substituting one into the other, that would be the 4th mark. Okay, and essentially getting the x value and the corresponding y value. Those are the 6 marks. But don't ignore this step. Question set coordinates. We need to show that in the ordered pair. And you can see that the final answer does not necessarily get a mark, but we have to present it. We have to present it. And essentially, guys, these are the 19 marks of this question. I apologize for the background noise. There's guys under the tree there. They're just chatting. So I have a very big tree in the yard. So they go and chill there. So sometimes I'll talk like they're next to me, but I'm inside and they're outside. All right, folks. So this is essentially, how to deal with this question. Can you see, when you know you can take this down, bank some time and do it fully, so that when you need to jump, you quickly do whatever you can and then get back. But when you can handle it, do it. And the manner in which you can do it, check the questions and see if you've got a plan for each. Then the one that you don't have a plan, automatically jump it, because you will be in trouble if you do not jump it. Okay, let's look at question 4. All right, let me just get my water quickly. All right, guys, so let's carry on with question 4. Again, we read the statement given. This is purely a grade 12 question, or let's just say mainly grade 12, but some grade 11 work may be necessary depending on what we see. It's mainly grade 12 though. In the diagram, M with coordinates 1 and 3 is the center of the circle. Okay, that's good. Now the circle cuts the x-axis at N, so that's fine. So it means we've got some x coordinate, but the y value must be 0 because this is the x-intercept. Now ST is a tangent. ST is the tangent to the circle at P. So, okay, now with those coordinates 3 and 9. So what do we know? We know, guys, that essentially the tangent meets the radius at right angles. Okay, So this is tangent perpendicular to radius, because this is the line from the center to the tangent. That would be the radius. Okay, now that's what we know at this point. And then of course we have some 10 chord theorem coming through. If we are to know that angle, it should be equal to this angle. Okay, maybe let's make it smaller so that we don't mess up too much. So those two are equal. That would be the angle between the tangent and this chord equal to the angle subtended by that chord at circumference, provided this is a straight line, OC. And we are told R with those coordinates D and 1. So this is a question mark. It's a potential question right there with D greater than 0. Can you see? More information provided, more compelling evidence that this is going to be a question, or it will be necessary. Now, we were told R with those coordinates with D greater than 0 and L lie on the circle, so meaning these are concyclic. They are at the circumference of the circle. Okay, O and V are the x-intercepts of PL and RL. Now once we say x-intercept of PL, it already tells us that this is a straight line. And then RL respectively, and again RL is also a straight line. Okay, great. So there's many ways of trying to give the same information, guys, to make it clear that we are dealing with some higher, pieces of information. So we need to be able to appreciate these always. So what can we do, guys? Well, we've got the center, we've got a pointed circumference, so we can find the equation of the circle. And what about the tangent? We know that it is perpendicular to radius or diameter, and we've got 2 points on that diameter or radius. So we can use that property that the two gradients will multiply to -1 to find the gradient of ST. From that gradient of ST, we use this point, we find the equation. From the equation, we can find the y-intercept, which is the y coordinate at S, because the x coordinate is 0. Nice. So what else can we do? Well, if we have the equation of the circle, we can substitute point R to sort out D. So we can find D as well. Is there anything more? We can find the equation of, remember this is a midpoint of the diameter. So M is the midpoint of the diameter. These are ready. And this means we can find the coordinates of L. And we expect them to be both negative because it's a point on the third quadrant. Now we can use the midpoint expression here, it can help us. Or we can just use, logic and symmetry. So if we look at point P, if we take point P and transform it to point M, what did we do? We moved from 9 to 3, so we subtracted 6 units down. Then to move from 3 to -1, we subtracted 2 units to the left. So the same way, we're going to move this point down here. We're going to move it down 6 units, so 3 minus 6 is -3. So this gives us -3. And then we move this point to the left 2 units. 1 minus 2 is going to be -1. So those are the coordinates. Can you see? Very important. Again, be careful. We just did it. And since we know we're going to find the coordinates of R at some point, we can find the equation of this line. From the equation, we can read the y-intercept and work out the x-intercept. And we can even find the angle of inclination if we need to. And we can also find the angle of inclination of PL. All right, so that's it. That's it. So there's a whole lot of things we can do. So this is a very good question. Anyway, let's not waste time. Let's see how many questions can we answer so that we choose our battles. Write down the coordinates of L. We can do it 2 ways. Determine the equation of tangent ST. We can do it. Show that the equation of the circle is like this. We can do it. Show that D is 7. Again, if we get this, can you see? The examiner is being friendly here. He's trying to give you a checkpoint, meaning if we get this right and we used information from above at some point, it simply means those calculations above are essentially correct. Then we need the size of L, so that angle. So how could we find it? Well, if we look here, so if we look at this small triangle, what do we see? We can see that we've got this angle right here. Okay? And we want L. But PL makes this angle as well. With the x-axis, we can call this one alpha. We can call this one, remember this angle is vertically opposite this angle over there. Now, we can call this one beta. Okay, that we can call beta. So can you see, knowing that we could do this gradient, that can help us to find beta, which is vertically opposite that inside. And so these two will add up to the alpha outside, which we can also find from, that gradient of that PL. So we can use the exterior angle of a triangle to sort this angle L, or we can calculate the length of PL, length of PR, and length of LR, and we can use the cosine rule. Okay, saying the square on that side is going to be the sum of these minus 2 times the product of these multiplied by cos of this included angle. So we've got options. So can you see, this is easy. We've got 2 options to sort it out. Easy, 5 marks, and obviously this is a higher grade question. Now TR is a tangent to the circle at R. Okay, so now if we've got a tangent, we can just draw it all the way to point T. All the way to point T. Now any construction that we make must be in a broken line. Okay, so we need to prove that these two are perpendicular. So it means for this one to be the case, we're not sure. I'm going to put it in black. So we want to find out, is this so? Is this the case? Well, we know that we will have found the equation of ST. From there we have the gradient. Then we take the gradient of ST, then we multiply by the gradient of RT. If it gives us -1, we are sorted. But what would be the root to that? We would still need to construct this radius as well. Okay, if we construct this radius, we know that it is itself perpendicular to the tangent. Okay, it's perpendicular to the tangent. So we can use that property because we'll have the coordinates of R, we have the coordinates of M. So this can help us to find that gradient of RT. Simply multiply to that gradient. If we get -1, these two are perpendicular. So again, easy question, but I would qualify it as, one of those higher order type of questions, but low-key killers, essentially. So guys, we can see that we can take any battle here. So we bank our marks. Analytical geometry is usually like that. We can get more marks in it. Okay, write down the coordinates of L. We saw how we're going to do it. Question said write down, so we can write answer only. L is -1 is to -3. Of course, a student who doesn't know, we can show you how else you could do it. If you don't want to use this transformation of transforming this point to the midpoint and transforming it down to that end of that line. So you just check from P to M, we moved from 9 to 3. So we subtracted 6 units. So we shifted that point down 6 units. Now to move from 3 to 1, it means we shifted this one horizontally to the left by 2 units. 3 minus 2 gives us 1. So this will shift to this point in the same manner as it did there. So we take this one down 6 units down. So 3 minus 6 is going to be minus 3. Then we shift this point to the left by 1 unit. It's going to be 1 minus 2. It gives us minus 1. That's how we get it. But one can also do it like this. Let me just show this one just for enrichment. So we know that L is such that x at L plus x at P over 2 should give us the x coordinate at the midpoint M. Likewise, y at L plus y at P divided by 2 should give us the y at M. Okay? This implies that L is going to be x at L still plus x at P. This is 3 over 2 should be equal to 1 is to y at L plus y at P, that's 9 over 2 equals 3. Okay, so therefore our L, we cross multiply the 2 there, we transpose the 3 to 2 minus 3 is minus 1. Cross multiply the 2, we get a 6. Transpose the 9, 6 minus 9 is minus 3. Okay. This is the most standard way to do it, but again, when a question allows to use simpler methods, learn to trust yourself even on those so that you can work it out nicely. Alright, so again here guys, the marks are on those coordinates by any means you have used to sort them out. So 4.2 says determine the equation of the tangent ST. This is a nicer question. So we know that the gradient of ST, the tangent, multiplied by the gradient of PM, the radius, should be minus 1, because we know the tangent is perpendicular to radius always. So this means the gradient of ST into, now we can just simply say y at P, which is 9, minus y at M, which is 3, divided by essentially x at P, which is 3, minus x at M, which is 1, is going to give us minus 1, like that. Sometimes I like to show this gradient in case I will need it elsewhere. So gradient of ST into, this is 6 divided by 2, which is going to be 3. That's a fairly steep gradient. This is a third. So we can say therefore the gradient of ST is going to be minus a third. Okay, that's good. Well, it's a less steep gradient and it's negative, so that's good. We can accept that. What can we say? We can say here then, we know that ST, the tangent line, is such that y is equal to minus 1 over 3 x plus c. Now through that point P, which is 3 and 9, to such that 9 is minus a third into 3 plus c. Therefore our c is going to be, this is minus 1. When you transpose, it becomes 10. Therefore, y is minus 1 over 3 x plus 10. We can see that the y-intercept is not so far from that point. So that would make sense to be 10. So we can accept this answer nicely. All right, so what is important here? This is 4 marks. So for me, it is calculating the gradient of PM and then calculating the gradient of ST as a result, substituting the point and getting us the final equation. Okay, let's move on. So 4.3, we can do it here. We need to find the equation of the circle. So we can say circle M is going to be x minus the coordinate there, all squared, into y minus the coordinate there, all squared, is equal to r squared. Okay, now we can use any point. We can use point P. So this means we're going to have 3 minus 1 all squared plus 9 minus 3 all squared equals r squared. Therefore, r squared is going to be, this is 2 squared is 4, this is 6 squared is 36, 36 plus 4 is 40. So we can say therefore the equation now is minus, maybe let's not say therefore, this implies that, which also implies that the equation is x minus 1 all squared plus y minus 3 all squared equals 40, but this is expanded. So this also implies that this is x squared minus 2x plus 1 plus y squared minus 6y plus 9 equals 40. Therefore, x squared plus y squared minus 2x minus 6y, so that is good. So we've got 1 plus 9, that's 10, minus 40, that is minus 30, is equal to 0. So a bit of work here. Now we are sorted, so this substitution is key, or in fact we can just say, writing it in standard form, substituting a point, getting that in that manner is good. And of course this expansion, because this is already sorted for us. Easy, 4 marks. So 4.4, we need to show that D is that point. So we know that circle center M, no, not U. Circle M is given by X. Okay, maybe let's write it the other way. So this is x squared plus y squared minus 2x minus 6y minus 30 is equal to 0. Okay, we can say now through point R, where x is D and 1, so we put D here, squared plus 1 squared minus 2 into D minus 6 into 1 minus 30 equal to 0. This implies that we have D squared minus 2D. Then we're going to have 1 minus 6, that's minus 5. Minus 5 minus 30 is minus 35 equal to 0. This implies we can attempt to factorize. So this is D, this is D. 35 is basically 7 and 5. Now to get it to, this is minus 7, this is plus 5. Okay? So therefore, D is equal to, remember D is in the first quadrant, so it has to be the positive answer 7. So that confirms that we did well with our equation. So if we doubted that our actions here, but again the equation was given, so it means everything we did here is good. We can accept it. But this one has to make sense for us to say it's correct, okay? Literally. And if at all you used point L, just to be sure you did it well. But I mean, if you do 2 techniques and you get the same answer, chances are you are doing the right thing. So no need to panic here. So how many marks? 2 marks. Obviously this is just substitution and selecting the correct answer here and neglecting the other one. Although the answer is given, we have to justify that. This is a point in the first quadrant, so D must be positive. Okay, so 4.5, what are we doing? We need to calculate the size of angle L. Okay, now we can choose to do the cosine rule in the bigger triangle. So we can choose to do the cosine rule in the bigger triangle, but I'm going to work with the smaller one. It looks okay. So we're going to say let angle of inclination of PL and RL be alpha and beta respectively. Okay, always set up the mode at times. It helps a lot because we don't want to end up using a whole lot of complicated stuffs. So what we're going to say, we can say then in triangle, say LOV, love. What must we say? We're interested in that angle. So we know that this angle OVL is basically, in fact, let's do this. We can simply say tan angle OVL is going to be equal to tan RVN. Okay? Because that would be that angle. Alright. The reason is we know that these are essentially vertically opposite angles. These are the angles. Now their tangents are going to be the same. Okay, so this implies that tan OVL is going to be equal to, now the tan of RVN is essentially going to be the gradient of RL, because that would be the line that gives us RVN. Okay, so we go on again and say, fine, we've got tan of OVL. Now we don't need to write the formula, we jump in. So this is 1 minus 3 divided by 7 minus 1 is like this. So this implies that tan OVL, writing as a tendency, this is 4 over 8, which is a half. Okay, we can simply say therefore OVL is equal to arctan of 0.5. Now we put it on the calculator. Shift tan 0.5 gives us 26.565 degrees. So the intermediate answers we don't rush, okay? We take a bit of time. So we can say here also, we know that tan alpha is going to be equal to, did we at any point find the gradient of this line? Yes, we did. Because remember, the gradient of PM, since this is the diameter, is going to be the same. So do you see when we wanted to show this gradient right here? The gradient of PM is the same as the gradient of PL. So we just take it from there and plug it here. It's going to be equal to the gradient of PL. This implies that tan of alpha is equal to actually, I don't know why I did this. I shouldn't have done this one. I should have just written 10 beta. Why did I say beta and not use it? Dang. Yeah, man, that is the one. That is the one. Okay, guys, so tan of alpha is basically equal to 3. Therefore, alpha is the arctan of 3. So shift tan of 3 gives us 71,565 degrees. All right, okay, all right. Now what we can do, we can just try to push this up to save a bit of space. We can push it up there. So what we can do now, we can clearly see and appreciate that, well, now in this triangle LOV still, we understand that essentially angle L, maybe we can write here then, angle L plus angle OVL should be equal to angle alpha. This is the exterior angle of a triangle. We're still talking about that triangle. This implies that L plus OVL, this is 26,565 degrees, equals 71,565 degrees. Therefore, our angle L is going to be the difference here. So we say minus 26,565. So this is essentially 45 degrees, okay? Makes a bit of sense. We can take it down as our answer, okay? So we have done it, guys. Not a very bad question, but one of those questions. Now what must we do here? I do believe that this relationship is key. This gradient, we did not calculate it elsewhere, and boiling up to that angle, very important. But here the main issue is the angle, the fourth mark, and we can essentially mark the answer here. So this is 5 marks. For me, this could easily have been 6 marks because this is pretty important, you know. This is a very strong reason. Maybe we can drop the mark there. It's not really a strong one, but this is what can be considered for the mark. Okay, guys, let's not relax too much. We don't have much time. How did we not finish this properly? We jumped a lot of spaces, did we? Okay, all right. So 4.6. We need to do this one. This is now easy. So we need to prove that this is the story. So what can we say, guys? We will say firstly, gradient of RT multiplied by the gradient of MR. Say, let's say RM, okay? Must be giving us -1. The tangent is always perpendicular to radius. All right, So the gradient of RT into, we can just jump in here. This is nothing but 3 minus 1 divided by 1 minus 7. This is equal to minus 1. So we're not really interested in this gradient. We can just jump in and say the gradient of RT is going to be, this is 2 divided by minus 6. So this is minus a third. When we divide by that, we get 3. That makes sense. It's a very steep gradient. And by the way, if this is 90 and this is this is 90 and that is 90, okay, let's not say a lot. It's not exactly what I want to say, because if we prove then that this is 90, we can only say these are parallel lines. We don't really have the grounds to call it a square as yet. Okay, now let's have a look and see what is going on. We can actually call it a square. Why? Because the gradient of RT is equal to the gradient of PM. So if these are equal gradients, these are parallel. Okay, if these are parallel lines, that is 90 degrees, that should be 90 degrees. Those are co-interior angles. You can approach it that way. Not a big deal, but I'm going to choose the other way that I thought about. We can say then, we know that the gradient of RT times the gradient of ST is going to give us, this is 3 times, we got minus a third here. This is going to give us minus 1. We can say, therefore, we have proven that PT is certainly perpendicular to RT. That is the conclusion. So that's good. That's good. So if we like here, we can actually use PT instead of ST. But we know P and T and S are collinear points, so the gradient would be the same. Very interesting question, not very complicated otherwise. So what is important is this and that and the conclusion thereof. So sometimes the conclusion as it is given to us, we can still use it to answer some questions. Okay, so you can see, guys, here analytical geometry can take a portion of your time, because each question is plus minus 20-25 minutes, depending on how fast you are, of course. But here I'm trying to take you slowly in and get it done, but maximum 25 each. This is about 50 minutes, and I think that's more like what we used here. All right, so let's move on to trigonometry. So can you see, guys, we know that we are scooping marks, and we have checked to show, to make ourselves convinced that we are scoring those marks. Okay, so question 5. So now we're going into algebra of some sort. Anyway, guys, so this is going to be 5.1. Okay, all right. Okay, so guys, we just redraw this diagram right here. We just redraw it. Origin, and we anchor it on the x-axis, so that we've got 90 degrees there. So we've got P, which is -3 and -4. That's a point on the third quadrant. So this means this length is -3, or 3 units. minus 4 over there. So we need to find r. Okay, so we know that x squared, in fact, we can just simply say r squared is equal to x squared plus y squared. This is from Pythagoras. Yo guys, I'm feeling tired. X squared is minus 3 all squared plus minus 4 all squared. So this implies that r squared is, this is 9 plus 16, that's 25. Therefore r is 5 units. If we like, so we can just write 5 over there. So this calculation must come quick. No need to waste time. Of course, this is provided in your answer book. You don't have to draw it. All you have to do is just to anchor it. That's all. Okay, we can start answering some questions. 5.1.1. We need to find the cos of A. I did not even indicate the angle. Okay, so we know that cos of A is going to be adjacent. That's minus 3 over hypotenuse, which is 5. That's the answer. Usually this is just a grade 11 thing, but the second mark comes from there. Okay, nice and easy. 5.1.2, we need to find the cos of 2A. This is equal to, now we can see this is a double angle identity, and we've already got cos here. So we can easily say this is 2 cos squared A minus 1. This is 2 into minus 3 over 5 all squared minus 1. Now remember, we deal with ordinals before we do multiplication in a way, or we deal with this bracket, if you think about it that way. Now this is going to be 9 over 25 minus 1. Then this multiplies, we get 18 over 25 minus 1. Now what I do, I multiply there. So 18 minus 25 gives me minus 7. So this is going to be essentially minus 7 over 25. Okay, so depending on the choice of the approach, you can do it this way, or one can write cos 2A is equal to cos squared A minus sine squared A. This becomes minus 3 over 5 all squared minus, now the sine there is going to be minus 4 over 5 all squared. Now what is this? This is 9 over 25. Sorry, minus, this becomes positive 16 over 25. So 9 minus 16 is 7. And of course, we've got a minus 7 over 25. Same answer. So this is another option to look at it. So you can even explore the third identity just to show you can do anything here. We leave it at that and move on. How many marks? 2 marks. So usually the expansion and substitution more important, and the final answer. So that's it. That's it. So now we've got another question here. Maybe we should do it here. 5.1.3. We are given that sine of angle B is 4 over 5. Okay. Now we are told that this angle is between 360 and 90. So this place is already that in the second quadrant because sine is positive in the first and second quadrants. So this is here. Okay, nice. So this is angle B. Essentially. So sine is opposite, so this is 4 over hypotenuse. This is 5. So we know that x squared plus y squared equals r squared. From Pythagoras, this implies x squared plus 4 squared equals 5 squared. This implies that x squared plus 16 is equal to 25. Implies x squared is 9. Therefore, x is minus 3 because this is in the second quadrant. Okay, so this is good. This is good. This is good. Now, we can answer the question. So it says, essentially sine of a minus b is equal to, and remember guys, let me warn you about something. Some of you in this kind of a question, you would substitute here and then find yourself getting the answer. It means you used a calculator. We need to see all those steps because the instruction is without using a calculator, and this is to suggest show all the steps. So be very careful. Again, don't do this. Here, you can't do this and then you show up with the answer. You will lose marks. Don't do it. So simple questions have a tendency to be naughty. Now, we can expand this. This is going to be sine of the first angle, cos of the second angle. The sign remains. This is going to be cos of the first angle times sine of the second angle. This is the compound angle identity for sine. So what is sine of A? Well, sine of A, we saw here that is going to be minus 4 over 5. So minus 4 over 5. Into cos of B, this is minus 3 over 5, okay? Minus into cos A. Cos of A was given as, or in fact we calculated it as 3 over 5, minus 3 over 5. Into sine B, this is 4 over 5. Okay, let's sort this out. This becomes positive 4 by 3. This is 12 over 25. Plus, because negative times negative is going to give us positive. This is still 12 over 25. Common denominator is 25. Then 12 plus 12, that is 24. Okay. Nice question. Easy stuff, honestly. So we get a mark here. Nice. And we get a mark for the left hand side. We get a mark for the right hand side. We get a mark for the answer. Again, usually doing the expansion is part of the 3-step approach. It could be marked. So we can say general substitutions as well as the expansion, 2 marks in that answer. So this is how we score those 4 marks in that question. Alright guys, so let's have a look here and see. So let's try to do 5.2 here. We're told if cos of alpha is equal to p. Now, normally we want to do this as a ratio, but remember, we're not given the constraint as to where cos alpha is. Now, this could be anywhere, so we leave it like that. We don't draw a diagram. Express the following in terms of p. Okay, so what do we see here? Now, a bit of inspection, guys, sometimes helps. We've got cos multiplied by sine of the same angle. So when do we get this kind of a product? Think of double angle identity for sine. Sine 2a is going to be 2 sine a times cos a. Can you see there is that product? But now we are missing this 2 in there. And now we are dividing this by 2 all of a sudden. So what are we going to do? Now the logical plan here is to create a double angle identity like that so that we can reduce it to this and then solve further. So what would be the logic? In maths, we are allowed to multiply by 1. But when we multiply by 1, this is effectively the same thing, but we're going to be strategic. So we've got cos of alpha over 2 minus 45 degrees times sine of alpha over 2 minus 45 degrees. This is all over 2. Now we can simply say this is the same as, we can start with the sine of alpha over 2 minus 45 degrees times the cos of alpha over 2 minus 45 degrees, all of this divided by 2. But when we multiply by this 1, we can be strategic in maths. We can do it like this. Now why are we choosing this? It's because we want this 2 to show up there. This is that 2 that we're trying to get in there. So can you see, in the summary we talked about using logic. So this can help a lot. Now when we multiply here, we end up with 2 sine alpha over 2 minus 45 degrees times cos alpha over 2 minus 45 degrees. This is all divided by 2 times 2 becomes a 4. So the numerators multiply, the denominators multiply. And we can simply simplify this thing back to what it was. So this is good. But we wanted to use this as a means to an end. Now let's have a look. Now if this is expanded, what can we do? We can contract it. So this is the same as sine of 2 into alpha over 2 minus 45 degrees, using the third step in our 3-step approach over 4. Now we distribute this negative using our brackets, BODMAS, as we know how. What do? We get sine of 45. This gives us minus 90 degrees. Plus, here we just get alpha. I'm writing this strategically so that we can answer the question easily. Now guys, if you look at the Cartesian plane, what do we have? On the Cartesian plane, minus 90 is here, right? With the origin there. So if we're saying minus 90 plus, it means if we add, we move anti-clockwise. So this means we are moving like that. So when we move like that, this is what we do. But now remember, 90 or 270, this is effectively 270. When we add an angle, we use cofunctions. So what is the cofunction of sine? It's cos. But sine is negative. in the fourth quadrant. So this is going to be minus cos of the angle. Can you see? All over 4. Okay. So this is essentially, guys, how this thing works out. Okay. So how do we then sort this out nicely? So this is as good as minus a quarter of cos alpha. So you can appreciate that we were told to express the following expression in terms of P. Oh yeah, not an answer yet. Not an answer yet. So this is going to be equal to, what were we told? Cos of alpha is P. So this is minus a quarter of P. Or we can easily look at it as P minus P over 4. It depends on how you want to see it and how you want to do it. Fact of the matter is, do it. So you can see, guys, shorthand techniques of doing things are very helpful. You need to think about them. But you can still go about the long route. If you say negative angle, you add 360 to it. And. At the end of the day, you will get where you need to go. Some people may choose to factor this negative and change this to positive and that negative. So that can also work. So at the end of the day, our trabajo es termina. So we're done. So make sure everything has been checked and double checked and triple checked, because this can be a whole lot of work. Now guys, this logical step here. Remember, when you use any of our 3-step approach to solutions, we get marks. So that is important. And then once we reduce this using double angle identities, that is good. And breaking these brackets per se is not a mark, but once we get here using reduction formulae, that is good. Okay, essentially. And then substituting to give us the final answer, that gives us 4 marks. And then this is for a total of 12 easy marks. Okay, so these questions are not too difficult, guys. Please make sure you get the answers. Okay, make sure you get the answers. This is not difficult. This is not difficult. Remember, this answer here is an option of how you would want to present it, or you can just say it's a quarter times P or a quarter of P, whatever. Nice. Let me drink some water. Okay, we're losing time and we're losing it fast, guys. I don't like it. Okay. So we can see, we can appreciate, and we do our things. We do our things. Our tag diesel. So the tags must do the tagging. All right. So that's it for that question. Let's get to more algebra of geometry. So this is a geometric algebra, if you think about it. So let's get in 6.1. We are given that cos of x minus y is going to be cos x cos y plus sine x sine y. Okay, this is more of an identity, of course. Now we are told to use the compound angle identity above to derive the formula for this one. Very easy. So 6.1.1. We know that we have cos of x plus y. this is going to be equal to the same as cos of the same angle, but what I'm going to do is going to be x. We factor out a negative. This is going to be good. So again, logic. I've summarized this thing for you guys. Now can you see between x and y we have a negative, which is what we have. So this is what we aim for. So this is going to be again the expansion according to that. Now cos of x, cos of minus y. The sign changes to plus sine of x times sine of minus y. Now cos x, now cos of a negative angle, this is in the fourth quadrant, so this is going to be positive. Okay, using reduction formulae, this is plus, in fact, this positive times, okay, maybe let's first work it out, sine x into, when we reduce this, it becomes minus sine y. Because sine is negative in the fourth quadrant, so this is going to be cos x, cos y, not minus, not plus, but now positive times negative, it becomes negative, sine x, sine y. That's it. So it's done. So it's just 2 marks, guys. So I think this logical step is good, and the final expansion. This could be more marks, but let's leave it here. It's not a big deal. Because whenever we use reduction formulae, we get a mark. Whenever we use reduction formulae, we get a mark. So we have a total of, say, the mark there, the mark here, you know. So 2 more marks. We can make it 3 marks, to be honest, and 4 because this needed to come out as well. So it's okay. They're giving us half for something worth double that amount. It's not a problem. 6.1.2. Hence or otherwise show that this thing is equal to that thing. Okay, so you can take this as proving an identity. You can say the left hand side versus the right hand side, or you can just take this and push it there and you stop. Sometimes when it's an equation, whatever you do, but this is nothing but proving an identity, to be honest. So we can just say left hand side is cos, do I have enough space here? Cos of 90 degrees minus x times cos y into sine of minus y times cos of 180 degrees plus x, all divided by cos x, cos of 360 degrees plus y plus sine x, sine of 360 degrees minus x times sine y. Alright, so again we follow the 3-step approach here. Now we first handle brackets. These are cofunctions. This is the first quadrant. Cos is positive, so its co-ratio is going to be sine x. Okay, we reduce it. Times cos y. And then plus. Now we reduce this, it becomes minus sine x. Okay. Into cos of 180 plus. Same function is going to be cos. Sorry, not just cos, but minus cos x, all divided by, we sort this out, is cos x. Now 360 plus is in principle first quadrant, so same function, so this is going to be cos y positive, and here plus sine x which is, sine of 360 minus x, that's the fourth quadrant. So this becomes minus sine x times sine y. Okay, good. So we've done our reductions nicely. So we can just do the product here. So obviously sine, cos, we can just leave this one as sine x cos y. Negative times negative is positive. The sign becomes positive. We can start with cos x. What? So this is y. Okay. So when this is busy, guys, it's easy to make a mistake. So we're starting with cos x sine y all over divided by cos x cos y. Positive times negative is negative. We can say sine x sine y. Nice. So what do we see? Compound angle identities expanded. We can shrink them or reduce them. So this is sine of the first angle. This sign doesn't change, and then plus the second angle divided by, this is cos the first angle. The sign becomes positive. It changes for this one like that. Now whenever we see sine of the same angle divided by cos of the same angle, what is that? The tan identity. So this is tan of x plus y. That was the right hand side. Okay, so done nicely. So another person can just easily reduce it to here and leave it here and say that's the answer. It's not a big deal, but it's an identity, so we are good. So how many marks? 6 marks. Good. So every reduction here gives us a mark. That is a good reduction. That is a good reduction. Good reduction, 3 marks. This is a good reduction, 4th. This is another good reduction, 5th marks. Can you see 5 marks in just one step? Because after that we just used brackets in the BODMAS, the standard style, and we don't get marks for that. All we got here was this. But now, what else do we get? We get a mark here for reducing these compound angle identities. Okay? Now whenever we use that, we reduce these, 6 marks. And then of course, using the tan identity to get there, but this was already given, so we don't get a mark for it. Okay, so that is 6 marks in a nutshell. So this is how you handle trigonometry, and you can easily see this is a combination of grade 12 compound angle identities, double angle identities, as well as grade 11 cofunctions, corratios, and what. Okay, do we have enough space? Maybe, maybe not. So 6.2, we have f of x is given by this dude. So here we've got 6 sine squared x minus 11 cos of 90 degrees plus x plus 7. Okay, all right, now we're told to solve for x in this interval. Okay, if f of x is equal to 2. All right, okay, all right. So what do we see, guys? So we know that f of x is equal to 2. So this implies that the square root of, maybe it's not complete, it's a bit longer, of 6 sine squared x minus 11 cos of 90 degrees plus x plus 7 is equal to 2. So obviously we do what we do. This is nothing but sets. Can you see this is now more like question 1 somewhere where we're dealing with sets and they're quadratic. Okay, this is it. So this implies that we've got 6 sine squared x minus 11 cos of this 90 degrees plus x, be systematic, don't be in a hurry, plus 7 is equal to 4. So this is 6 sine squared x. Now the question is, this is minus 11 into, this is a cofunction, so we can reduce that. This is the second quadrant, cos is negative, so will its its co-ratio, which is sine, see guys, I'm feeling a bit tired now, sine x plus 7, we can take the 4 to the other side. So we've got 6 sine squared x, negative times negative is going to be plus 11 sine x plus 3 equal to 0. Now we've got ourselves a quadratic, but we can't divide by 6 throughout or by 3 throughout. So we will attempt to factorize. Now this could be broken up. For us to get 11, we must have 3 sine x, 3 sine x. Everything is positive, so this must be plus 3 plus 1. Can you see this is 3 by 3, that's 9, plus 3, that's 11. And then this and that is, not 11 but 12, so this should be 2. Okay, so this is 9 plus 2, which is 11. 3 by 2, that's 6. 1 by 3, that's 3. So this is fully factorized. So this also implies that now sine x is minus a third only. Or we can say sine x is minus 3 over 2. Is this valid? No, this is minus 1,5. So usually sine of an angle alpha should be less than 1, greater than minus 1. Remember, that's the maximum and minimum of a sine graph. So this is already 1,5, so it's outside this domain. So we reject that answer. So we don't use it to solve anything. So we can simply say sine x, no, sort it out. This implies that x is going to be arc sine of this plus k times 360 degrees. Or this is going to be 180 degrees minus the shift sine of minus a third plus k times 360 degrees, where k is an element of integers. So this is usually, for me, easier when we do general solutions in this manner. So this also implies, maybe we can even conclude, okay, let's leave it. So therefore x is equal to, we use the calculator now, shift sine of minus 1 over 3. It gives us minus 19,47 to 2 decimal places plus k 3, or x is going to be that. Now think about it, this is negative and this would be negative, so this effectively becomes positive. So we just simply add 180 there, or we subtract 180. It gives us 199.47 degrees plus k times 360 degrees, where k is an element of integers. Okay, we are almost there, guys. We're almost there. So what do we say? We can say therefore x is equal to a set of values. So now we can try 0. Remember, we are given a domain. This is the domain. So this is good, because when we say x is 0, remember this is an angle in the fourth quadrant. Now an angle in the fourth quadrant is acceptable if you think about it. But my problem is that this is a negative angle. So this means we're doing anti-clockwise. We're doing a clockwise direction. So this is outside that domain. Remember, all these angles are positive. So if the angles are positive, so we want something that is in all the four quadrants, but going anti-clockwise. So this is what we want. Obviously, guys, so this is suggesting that we must not have negative angles here. That is the essence of this question. So let's see. This is less than 0, so we can take it when k is 0. So we get minus 19, but when k is 0, that one comes in 199.47 degrees. Okay, now the other one that we can get here, how about we say k is 1? So when we say k is 1, this one works, because it's going to be 360 minus 19.47. So this gives us 340.53 degrees. Oops, I think this is it, because this one works, but we need to adjust it so that it answers the question. And 340 is less than 360, so that's good. But if we put anything else, then this falls outside the domain, because this already falls outside when k is 1. So this is the two solutions, and that's the answer, guys. Now the question is, are these answers acceptable? Both of them. Remember, we squared. Can we then accept both of these answers? Then we go back. Remember, we must always run a check in what would be the original. Now the original here becomes what was given. The original is this one. Let's maybe highlight f of x must give us a 2. Of course, we might have to round off to the nearest integer there. So we take the square root. We say 6 into sine of whatever angle there is 199.47. We square that thing as a whole. So we subtract 11 into cos of this angle 90 degrees plus x is now 199.47. This one plus 7. Okay, let's see. Yo, I made a mistake, my lord. Okay, let's check. Where is the mistake now? Okay, I left one more bracket. Okay, be very careful here, but the cashier can take it. Can you see? This is definitely checking out. because I get a value of 2,0000, so this is approximately 2. Now let's try the other one, 340, because one of these answers may not be correct. So we've got 340,53 there. So now that we have a framework, we just change the angle, that's all. So I've got 340,53. All right. This also checks out. It gives us a 2. So this is good. So it checks out. Sometimes another answer may fit the domain, but it doesn't check out in the given expression. So be very careful. Because once we square, we may introduce solutions that don't exist. It is usually the problem. Anyway, now that we know what we are doing and we checked our answers, they check out, so we are happy that the check is good. So it means all that we did is perfect. Please remember these little pieces of information because it is very important. It is very important that sine of any hypothetical angle, when itself is not amplified, it has to be between 1 and -1. In fact, this is allowed. Yeah, that is the idea. The 1 and in between, -1 and in between is accepted. Okay, all right. So 6 marks, that is good. So this is algebra now. We get a mark for our gymnastic. Pretty intense stuff. Factorizing is pretty intense stuff. Okay, all right. So that is 2 marks. Selecting this one only and rejecting that one may be a mark. I'm not too sure. So we have how many marks now? We've got 1, 2, 3, 4, 5. So maybe the 6th mark could be these general solutions together, because they were our means to an end. But also rejecting that could be considered a mark, because these were nothing but a means to an end. What we needed was the answers, usually. So that could be considered. It will depend on the memo, of course. Anyway, let's move on. 6.3. Now 6.3 says we consider this function, okay. So we've got g of x is equal to 4 minus 8 sine squared x all over 3. All right, not a problem. So there's nothing much we can do here, but usually for this to be a function, we don't normally square our trig ratios because it becomes a horrible situation. Okay, as much as we can substitute values in there, but we can't really predict this nicely. So we need to modify this, especially when we've got terms. It means we can modify it. But let's look at the question. Sometimes you're not sure what to do. Let's look here and find stuff. It says calculate the maximum value of g. Now we can't really get the maximum value there like that. So we need to modify that. Okay, let's have a look. 6.3.1. We appreciate that g of x is going to be. Now, the logical thing to do here is to try and get rid of this square. But if we look here, we will see that between 4 and 8. So a bit of inspection, guys, is very important. 4 and 8, they have a common factor. So we can factorize. We take out the 4, we get 1 minus 2 sine squared x all over 3. Okay, good stuff. Now what do we do here? We will see that once we create this factorization, it leads to yet another thing. Can you see inside the bracket we've got the cos or cosine double angle identity expanded. Now we can contract it using our 3-step approach. So this implies that g of x is going to be 4 into, we then sort this out. In fact, we don't need to put a bracket. We can just say 4 into, this becomes now cos 2x. Okay, all over 3. Now when we have this, this is what we can do. We can look at it, because we can actually factor it out even more. Say this is 4, you can say maybe, just maybe, therefore g of x is going to be 4 over 3 times cos 2x. Now this is a proper function, because we know that this guy gives us the amplitude of this graph. And since there's no additions or subtractions, the maximum of this is when this is 1. So 1 by that gives us that. Minimum is when this is minus 1. Multiplied by that, it becomes negative. So we can easily say, therefore, the maximum is going to be 4 over 3. Done. Nice and easy. All right, very easy stuff. Okay guys, let's master our craft. And as I did give you a nice summary, this should be working handy. You can see that for us to decide to factorize here, it's logic putting us in that by inspection. Then from there we unlock something, and then one thing leads to another and eventually gives us the answer. So these are 3 marks. So what happened? When we factorize, we get a mark. When we shrink or use identities in any way, we get a mark. And of course, we get our final answer. Easy 3 marks. So we've got 6.3.2. This says write down. Now the question that says write down can be naughty. The smallest possible value of x for which g will have a maximum value in this domain, less than or equal to 360, but certainly greater than 0. And it's 1 mark. This is suggesting this. You probably want solution. But then we need to be smart about it. Even though it says we need to write down, we need to think about it. When will this occur? Okay, so we can think about it this way, that of course we get a maximum when cos 2x is equal to 1, isn't it? That's when we get a maximum there, because any other value is going to change this whole thing. Okay, because we know that cos of an angle, again, we know that cos of any angle theta must be less than or equal to 1, greater than or equal to minus 1. That gives us the maximum and minimum. Again, this is the story that we need to know, guys, and appreciate. Even if this is doubled, this is as good as angle theta. So this you can consider as just a single angle theta. So this is the story. So this speaks this sense. Hence we know that this would be the minimum value, and that becomes the maximum value. Hence I know I'm going to equate this to 1. Now we can say therefore 2x is going to be plus or minus arc cos of 1. Okay, so it means 2x is going to be equal to plus or minus 0. Now 0 in its true sense is just 0, so it doesn't help us, but this would imply that 2x is going to be minus 0. So minus 0 on the Cartesian plane, we know that this is 0 and minus 0. Minus 0 being nothing but 360 degrees. Okay, very important, guys, very important. So instead here we're going to use this and say 2x is going to be 360 degrees, because minus 0 arc cos of minus 0 is nothing but the arc cos of 360 degrees when we are going in the anti-clockwise direction, in the clockwise direction. So this is when we are doing things like this. Okay, can you see that? Therefore our x is going to be 180 degrees, and we can see clearly that 180 is less than or equal to 360, but certainly greater than 0. And we wanted just one solution, and this is indeed the smallest. Why? Because this is a double angle. Because remember, 180 times 2 gives us 360, so this is included. This is included. But we want the value of x, not 2x. So we can just simply write x must be equal to 180 degrees. Done. We get our mark. So this is a bit of a silly question. It's a higher grade question, guys. So if you know your work, of course you can work it out. If you don't, you will cry and die. In fact, this whole question, let's just say this whole question is a higher grade question. There's always these low-key higher grade questions in trigonometry. Be on the lookout for them. They are low-key killers. Alright, alright guys, so this is essentially good because we said the smallest. So smallest in literal terms means minimum. Obviously the next one would be 360, isn't it? Because 360 by 2, that's 540, isn't it? Or is it 720? 360 times 2, 720, ne? Yeah, 720. And we can see that basically cos of 720 is 1. Cos of 720 is 1, and that would still give us a maximum. Hence this is included here. Okay, but remember this is not the smallest. So the smallest is 180, and 360 is also included. But the question said smallest, so we don't take 360 because it's not the smallest. I hope, guys, this is clear. It was a very nice 18 marks where there were some technicalities for sure for a student. And I'm hoping you can appreciate the summary that I gave you at the beginning of this video and how everything seems to just tie up the logic, inspection, you name other things. If you watch all the videos I have produced in this channel, from the very beginning until now, I can assure you guys, there's no way you're going to fail maths. That's number one. Number two, you have a very big chance of scoring a distinction standard, meaning every math exam you sit for, you can score a distinction provided you work on yourself. You don't just watch and think you know. And you're not lazy as well to look elsewhere. And on top of that, if you are just a struggling student but who can pass maths, this can push you to a decent mark of 60 to 70. That can essentially put you in the degree of your choice anyway. So guys, be very careful. Some very good resources don't look so much. Once you find yourself bumping into them, just take it as a blessing in disguise. Sit in there and learn. I know some of you guys have an attitude towards these long videos because you're like, yo, but this finishes my data. I don't have time to watch this. Remember, you don't have to watch the whole thing at once. Watch the most of the things as you can. But in my opinion, long videos build your endurance. Remember, in the 3-hour paper, your life is at stake there. Your future is at stake, so you are anxious. And imagine you still have to concentrate for 3 hours. Not just concentrate, perform. Remember, you get hungry, you get thirsty, you are scared. You are more likely to crash out. So if you start now watching these long, lanky videos, they're not too long, guys. But watch them, and if you can concentrate for as long as these videos go, of course, trying to take smaller breaks in between, you build up your endurance. At the same time, you're building your well of knowledge. And guess what? You can now develop ways of getting to different positions of your well as necessary. And this is when you speed up in the exam. Like I said, if you have knowledge, you have the skill, you know how to approach papers, you will essentially answer questions in numbers in the shortest space of time you have available. That means you can bank the remaining time for the higher order questions that may not be so friendly with you. As I said, skim and scan questions when you can to choose the battles you need to fight now and fight them as quickly as possible but efficiently as well. Then move on. Others, you don't know where you're going. Things like this is nothing but algebra. Here you don't need to look ahead. You just do it. When you get stuck, you leave it, you move on. Do it. Get stuck, you leave it and move on. But the fact that you have done something, as you move along sometimes, certain things will come back slowly because that question intrigues your mind and it makes your mind fixate on it enough to solve it even while you're solving other easy questions. So there are many techniques, guys. I will not really have a situation where I sit in front of my camera and then I tell you these are the strategies in words. I would rather I tell you in action. So this is mathematics in action, guys. So I think any idea being propagated is better put to practice immediately so that you can see its utility and appreciate its majesty. Anyhow, that's it, guys. Let's move on to trig functions. Now this is the easier section. You can use this to relieve yourself of some pain elsewhere while you keep time, okay? You can relieve your stress here and your pain by using these questions in between heavy questions that somehow do some wonderful things to you so that you also don't leave the small questions until the very last moment. Although you can, because you can speed up, but sometimes you can trip and fall. Be very careful. So bank your time wisely. But don't focus on banking time now. I discourage you guys, and I discourage you with confidence because I know that's the reason you fail despite working hard or working diligently in a disciplined way. The problem is if you don't enhance your knowledge, you do not practice to make that knowledge user-friendly and flexible, you will not be able to save time. Believe me. Well, there are two situations anyway to look at. If you don't know much and yet you want to save time, you will barely pass. If you are lucky, you can just make it to the line, but you won't get far from the line and beyond the line, of course. Two, if you are an average student, of course you can use the technique of saving time so that you can keep your average mark, but that's all you're going to get. You're not going to get more than the average mark. But if you're a very good student and you study as best as you can, you do enough work, you are essentially disciplined, and you do perform the tasks that you are shown, you replicate them. Yes, you will struggle at first, but in the long run, you get it right and it becomes nice and sweet. You will definitely get a decent mark. That is high 60s to mid 70s and late 70s. Or even get beyond that, hit the distinction mark. And even worse than that if you are already sharp anyway. But that would also depend on whether you are taught well. So we've created these platforms, guys, so that you can learn relatively free. Remember, the data that you're going to spend watching this long video is cheaper than the lessons you can purchase for 30 minutes, 1 hour from a tutor who teaches a number of others alongside you, or even if you are tutored individually. The thing is, it will depend on the quality of that tutor. Do they really understand the subject enough to spark or ignite your already glowing nature of, ability in the subject? But if your teacher is just glowing themselves, maybe a slightly better glow because they're in a comfortable position, they're not under stress, so they may glow a bit better than you, but that's about what you can get, you see. So you need someone who's burning was exploding so that they can ignite you or provide you with oxygen for that glow to ignite into a fire. And then you can start burning things around. And we see you, we see you, we see you. Anyway, let's have a look at this question quickly. Question 7 says, in the diagram below, f of x equals the tangent of x. So this is a standard 10 graph. We don't need to say a lot. We know that the period of a 10 graph is 180. Always, unless it is modified. And of course, this can give us the intervals. That is going to be the current period in the graph divided by the 4 quadrants, which gives us 45 degrees. Now this becomes the spacing between the critical values, because critical values is what is important. For the 10 graph, it's an x-intercept. It's when the graph is at 1. It's an asymptote. Those are the critical values or critical points to consider for a 10 graph. If you look at the 10 graph along the origin, it is nothing but like a mother function of a cubic function, right? In algebra. So there's some relationships or relativity. These are relatives of some sort. Because the mother function of a cubic function has a point of inflection only. It does not have turning points per se. And this is exactly what we have here. The origin is the point of inflection here. But we can't really call these turning points, literally. They are just bands. Anyway, guys, so this is it. So be very careful, folks. Information like this can be key. Now, this is all I can say right now. But maybe let me highlight that the critical values here are the x values, which could be an x-intercept, the x value where the graph is equal to 1, and it could be an asymptote, x value at the asymptote. That's all about the critical values of a 10 graph. So I would call them critical values. So the spacing must accommodate these 3 things. An x-intercept, maybe y-intercept if it is shifted, it's not a big deal. But y-intercept is always at 0 anyway, so we don't worry about what x-coordinate that is. We look at the x value where the graph is equal to 1, or an asymptote of the graph. So these are the CVs, and this spacing can give us all of these. Then it gives us the proper shape of the 10 graph. And of course, we're given the domain in which this graph is drawn, and we can appreciate it. This is standard 10 graph. The asymptote is at 90 degrees, x-intercept as well as the y-intercept is at the origin or the point of inflection, if you think about it. Then another asymptote is going to be exactly 180 degrees earlier than the other asymptote. We can see 90 minus 90 is giving us 180. So that's the period of 180. And we can see the x-intercept again is doing exactly 180 degrees before, or we can say from here 180 degrees after. Then again 180 degrees after we have an x-intercept. So every point, critical point here. But we don't look at the rest of these points. We look at when x is 1. For example, things like this. So this is there. Not nice. This is better. So this is there. So this is meaning 45 degrees, so to speak. Okay, so think about those things. When the graph is at 1, it hits the 45 degree mark, so to speak. And of course, let's say 1 or minus 1. Ne? Because also this can occur right around here. We can see that we've got some arguments to make also in there. So we've got some arguments to make in there. So we get minus 1 where? At minus 45 degrees. Can you see that? So that is it. And then of course, every time, if it happened at 45 degrees earlier, we get 1 as well. This would be at 135, so to speak. And this is going to be at 135 as well. So minus 135 plus 135. So this is what we can see, guys. I'm not going to waste too much time analyzing here. But the intention is to make sure you guys understand, so that as we work through these problems, we smile our way through. So let's go for it. 7.1 says write down the equation of the asymptote of f in this interval. So from 0 to 180, this is 90. So x is equal to 90 degrees. Easy one mark. 7.2 says write down again the x values in that interval minus 80 to 0, this side now, for which f of x is equal to 0. This is interesting, isn't it? It's less than or equal to 0, so we know that x is in between less than or equal to 0. We have 0, and then greater than or equal to we can see that this takes the asymptote, so you can't say greater than or equal to, just greater than 90, sorry, not 90 but minus 90. Don't be careless when the question is easy. Basically we're saying the graph must be negative. We can see this graph is negative, that's less than 0, and it's equal to 0 there. All right. So this is what we write, okay? But what about these points? Because the graph is at 0 there, and this graph is at 0. And what else? It's less than 0 there. So, wait. Now, this is very interesting because we were given the interval, so I'm making a mistake. So 0 is included and 180 is included. So at 180, is it at 0? So we can say, or x is equal to minus 180 degrees. But this time we can't say greater because this is bigger and we don't have before that. It stops there. So we just write that. So essentially we get a mark for that and a mark for the other one, provided the notations are all correct in the values. Easy 2 marks. So be very careful. See the domain that was given, minus 180 was included and 0 was included. So you have to be very careful. Don't be careless. Sorry. Okay guys, let's move on to the next question. So we've got 7.3. Now 7.3, we are given a function. And then we are told to write down the period of this function. So easy. Period, we focus on the coefficient of the angle. There's a 2 there, and what trig function is this? Is cos. So cos originally has 360, but because of that 2, it changes. Now we know that the period here don't know, sometimes my writing is not bad, sometimes it's bad, but I guess it's just the increased psychomotor activity. I tend to just scribble instead of writing. So this is going to be the original 360, but we divide by the coefficient of the angle, which is 2. That is 180 degrees. So we can just write 180 degrees. That's not the question, by the way. The question is on 7.3.1. So 180 degrees, we take 1 more. So you see, these are easy questions. You can come and relax on these ones when you are feeling a bit hot, okay? 7.3.2. Now we're told on the grid given in the answer book, draw the graph of this function for the interval given and clearly show the x-intercepts with the axis, intercepts with the axis, be it x or y, as well as the coordinates of the turning points. Okay, not a problem. So we need to adhere to that instruction. So let's find that grade. Okay guys, so we have our grade. I mean, it's not too different from that, but I just wanted to show you some things anyway. So how do we do this? Now we know that if we want intervals here, it's going to be the current period divided by the 4 quadrants. This gives us 45 degrees. Can you see? Again, the critical values are going on the scale of 45 degrees. So this means we can say maybe halfway right here. Halfway there, this is 45 degrees. Because we need to accommodate each one of these ones. And then in between here, in 45 degree intervals, this is going to be 135 degrees. Now this here, I mean, I'm just approximating now. Try to be accurate though, because this grid is bad. This is minus 45 degrees. In between these two, with intervals of 45, we expect minus 135. Okay, good. Now this is what we need to see first of all. So we set up the grid to handle the business. Yeah man, yeah. And after that we just do the graph. There's nothing more. So we can see this is a very fast cosine graph pushed up by 1 unit. Now we start at 0. When this is 0, what do we see? Cos of 0 is 0. No, it's 1. Then 1 plus 1 is 2. So this one goes up there. It goes up there. Okay, all right, okay. So it comes up to 2. So that's the maximum. Now at 45, we double this. This is 90. Cos of 90 is 0. 0 plus 1, it goes to 1. So 1 is over here, directly above 45. And then 90 by 2, that's 180. 180, cos of 180 is minus 1. Minus 1 plus 1 is 0. We ground it. And then at 135, it's going to be 135 by 2, that's 270. Cos of 270, that's 0. 0 plus 1, we go to that level again. Essentially. Of course, guys, you need to, sometimes I just draw a horizontal line to not have a situation mess with me, you know. Sometimes I do that and just do some temporary lines because this thing is going to horrify me. Now you can see that it's already suggesting that I was going to run into some situation right here. Okay, so we can appreciate that this is over here. And this one is over here. Okay, now we can do now 180 is going to be 360. Cos of 360 is 1. 1 plus 1 goes up to 2. Okay, so what can we do now? We just delete those lines. Oh, let's not delete but extend them, because they will help us to move forward. Of course, try to use your ruler, because sometimes they give you a bad grid. I don't know why they did that. It's not right. It's wrong. It's a wrong. So of course here it's going to be symmetrical. No, you're lying. It's not going to ground. Remember, cos of a negative angle is positive. So it grounds there. There. Now once we have our points, we can then delete these lines. Okay, nice. Now we can draw our function nicely. Okay, let me just do it quickly. Okay guys, so there is our graph, nicely drawn, and we've indicated those turning points because they are flying, but this one is grounded at 2, so it's nice to see the x-intercepts are very clear, so we're not going to waste time. The points in between don't really matter for now, but they're good to consider. As you can see, they provide us points of intersection like this. Points of intersection, so you can see they are important. This is why doing all of this work, guys, is important. Now we can even check the maximum. Here it's 1 plus 1, it's a 2. The minimum is going to be minus 1 plus 1, which is 0. You can see that's the minimum, that's the maximum. Maximum, minimum, maximum. Okay, easy stuff. So guys, we've shown everything, so we get our 3 marks first. The mark is for the shape. Okay, we can easily say showing one of these coordinates of the maximums as we were asked to, and we can see the intercept with the axis are visible. We get an extra mark. So this is how we score those 3 marks. Okay, so that's it, guys. So let's do 7.4. Okay, now 7.4 says use the graphs to determine the general solution of this situation right here. Okay, this is definitely a higher grade question of some sort because it can cause pain. But we know how to handle things. We are going to do that. We are going to do that. So let's see. Now, what must we do here, guys? Now remember, we use these graphs to determine, but we need to do something. This is 2 cos cubed x minus sine of x equal to 0. So what are we doing? If we're going to use these graphs, it means this thing is either this graph of 10 or this graph of cos, which is this one, or both of them. So let's see. Now the key here is to try and say, let's try and create the 10 graph. And the easiest is to divide by cos logically. Remember, we can divide by anything in maths. We can divide by anything. Now this anything here, we are going to strategically choose cos because we want to create 10. So if we divide by cos x, we are going to get 2 cos cubed x minus 2 sine x. This is divided by cos x divided by cos x equal to 0 divided by cos x. So remember, guys, like I said, 3-step approach. Logic is part of it. Logically, of course, from inspection and knowing that whatever we have here, if we can use these graphs, it means it's related to them. All right, so this implies that we will have this cos takes the cube and leaves the square there. So we're going to have 2 cos squared x minus, this is the 10 identity. This is 10x equal to 0. Like, oh my God. We can move the 10 to the other side so that it's positive because it's given positive there. So we've got 2 cos squared x equals 10x. But now the question is, what is this? Now you can remember that from the compound angle identity, cos 2x can be expressed as 2 cos squared x minus 1. What happens when we transpose this one? When we transpose that one, what do we get? We get cos 2x plus 1. It's going to be equal to cos squared x. Now this means this dude is nothing but the function that we were given. So we can say this implies, we write it down, that this is going to be essentially 2. No. It's not 2, but it's just basically cos 2x plus 1 is equal to 10 of x. Can you see? It looks as if you are crazy, but you know where you got it from, and no one cares. As as long as you write the correct thing. Can you see now, this is the point of intersections of these two graphs. Can you see now, doing our intervals, even though mostly they don't work in our favor or they are not even looked at, but can you see they are proving useful? So doing this is not a joke, because now can you see we have those points of intersection that we highlighted right there. Now we can just simply read. We know that this is at 135 and 45. So we can just simply say therefore x is going to be essentially minus 135 degrees plus k times. Now what's the period? Remember the period of these two graphs. Again, let's look at it. When do they intersect? See, this is at minus 135 and then they're doing it at 45. That is an interval of 180 because 45 minus 135 gives us 180. So the period is going to be k times 180 degrees, or x is going to be 45 degrees plus k times 180 degrees, where k is an element of integers. Okay, this is great. Okay, cool. So this is what is important. Now, can you see, guys, a lot of logic. This is why this is a higher grade question, because even to determine the period here, you have to really be careful, because you may not know what to say. But if you look at it, I mean, if this is at 45, it's going to go again at a period of 180 degrees on top of that. So we just say 180 plus 45. That would be at 225. These two graphs are going to intersect again. So you can actually read from the graph, even though that you have a snapshot. From this snapshot or profile, if we think about it, we can actually read a lot. It's like settlement geography, where you just are given the profile of a city, and you can tell this is the CBD, this is the outskirts, and what. You can tell most of the regions around it by just looking at a profile. Okay, very easy stuff, of course, technical stuff at times. So this is easy, guys. So again, the logic of dividing by course, because how would you know you need to divide by course? It depends on what you inspected and what you want and what you understand. And from there, again, we're trying to create something user-friendly like identities. So we can easily see that when we do this obvious division, we don't do anything here. But this translates to the 10 identity that gives us a mark. That's the second mark. The third mark is when we realize that this thing is nothing but a double angle identity. That is essentially the third mark. In fact, the logical thing here, probably not really strong, but I think these two general solutions are fairly strong. But someone may consider giving a mark here, because why would you know you have to do this? Logically. Can you see, guys, the summary is not a joke, it's not a fluke, it works. So we have 4 marks. Easy. And we're sealing these 11 marks with a huge smile on our face, because we are like, okay, all right, okay, we've got this covered, and so we can handle it. Now let's finish the trigonometry, guys, and then maybe I can take a tea break, nyana, sell it and replenish and give my strength for my best, the beast. Usually Euclidean is the beast, but not always. Okay. All right, guys, let's get to this question 8 nicely. Okay. Question 8 says, in the diagram, C is the foot of a vertical building and D is the top of the same building. Okay, vertical building, and this is the top. Okay, this is the foot. That would be the top. Okay, maybe let's, And we know that this is a vertical. We can see that angle is indicated over there. And I like it like this. This 3D structure is nicer. Unlike just the story and these without the building. This makes a lot of sense. Okay. Now I told you that the height of the building CD. CD is the height of the building. Great. Is 16 meters. 16 meters. All right. Okay. So we know that. Fine. This length. What I like to do is to highlight things, though sometimes giving them a color helps me to think, okay, it's not exactly a vertical line, is it? Let's try it. Okay, let me try. Ewan, why are you off the mark now? I'm a surgeon, guys. I can make a straight incision without flinching, you know. Can make very beautiful incisions, but of course I eat because, hey, I have intention tremors. You see, my thyroidal tone is a bit high. I burn food. I lose weight fast. Although I chow a lot, I don't gain it fast. Anyhow, that's fine. It's my biology right there. I have a very strong metabolism in the catabolic side because of the thyroid hormone. And of course, I'm a very active individual, so I burn easily. So it gets worse. So anyway, guys, we know that this one is 16 meters. Very important. Okay. Now I told you that two observers are standing 9 meters apart at points A and B. Where A, B, and C lie in the same horizontal plane. We can appreciate that. Normally this is shaded. Let me do it. Okay, guys, so this is usually the case. Let me get my charger and put my tablet on a charger because I think I'm going to lose power pretty quickly. Right, guys, this video is going to be long for sure, but the intention is to create something user-friendly for you guys to follow and to have it under one video instead of searching for multiple portions of it. It is usually very helpful. Keeps the channel clean instead of too many videos of the same question paper. But I will create some shorter versions so that I can expand on some knowledge and ideas. And of course, I'll choose questions strategically that can help to enhance that knowledge in your mind and make you stronger. And then of course, we'll bunch them into a playlist so that if you watch one video, you see the others as well. Okay? But it will help you guys to subscribe. Not necessarily to make me popular. I really care very little about that. In fact, I don't care at all. But what disappoints me is the fact that I created this channel to supplement, you know, what your teachers are doing, what you can find elsewhere, so that you have the greatest experience, so that you can pass with ease. Guys, you have no idea the difficulty and the pain we had to go through to elevate ourselves to this level. Our education got attacked during Sir Kada Asmal's time. And I blame that man. Why did he assign that thing and advise our presidents to adopt that stupid education? Because that is what actually initiated the kill in the quality of the execution of our education. In fact, they started trying to make the actual education dizzy. And then on top of that, it then impacted negatively on the quality. Because remember, those old teachers who taught us, who still maintained what they were taught and what they knew was better, are retiring. Others are dead. Now it's only the young ones who care to be on TikTok and dance and treat matriculants like they are doing grade 1 or kindergarten with recitations. How are those kids going to take themselves seriously? They need to be taught like babies. That's ridiculous. But you see, the problem is trying to be popular, because these guys are just trying to be popular. And you see the dress code is ridiculous. You see a teacher wearing like one of these students, and how are these students going to see this person as a person of authority and respect them? They won't. And you don't wonder why these kids have no respect. Again, the way the very teachers treat these guys, even those who are older, they tend to argue with kids. You don't argue with kids. You order kids around. That's what you do. Okay? And if they don't do it, you just drop your wrath on them as in punishment, and you don't play. At the same time, you can make them comfortable around you. They can express their knowledge without fear of being wrong. That is not important, as long as this is controlled and it's focused. Okay, anyway guys, I'm gonna talk. Let's finish this before we hit this 4th hour, because time is not on my side. Okay guys, so we see what we have and what can we do now. It says a painter working at point E. Okay, at point E we've got a painter on the building. Now the angle of elevation of D, okay, the angle of elevation of D from A is 46,85, so that's indicated. DEB, so this angle is 122 degrees, it's already indicated. And BCA, it's 105,61 degrees, also indicated. So now this is very good. So now the first step, guys, is to calculate. Now when we deal with a 3D, you calculate all possible angles. That's the first thing. So can we? Yes, we've got 90, we've got 46. We can actually look for this angle, and that angle is going to be essentially 90 degrees minus the other one, because they're complementary. So this is 46,85 taken from 90. We get 43,15 degrees. Okay, good. Not a big deal, not a big deal, not a big deal. So sorry guys, let me see, maybe I'm doing something wrong, but I don't think so. Yeah, that's good. So we've got everything under control there, so that we can do. So what else can we do? We see this is 90, you see this is 122. So in this triangle, if we look at this triangle, maybe let's give it a red outline or this orange outline. If we look at that triangle, since this is already outlined like that, if we look at that triangle, what do we see? That's an exterior angle. This is an interior opposite angle. It can add up to this one. So we can say, okay, this one is essentially 122 minus 90. 122 minus 90, it gives us 32. Okay, or we can say these are angles on a straight line. If this is 122, so to make 30, this must be 58. What color can we use? Maybe blue. So we can calculate this from angles on a straight line. So this gives us 58 degrees. Okay, great stuff. So not a big deal. Not a big deal. All right, good. So folks, we are on fire, are we not? So that is the first thing we do. What is the second thing we do? We choose the triangle to start with. We start on a triangle with most angles and at least one side given. Okay, we start on a triangle with most angles and at least one side given. Okay, now what do we see? This one is the one with the most. Okay, so guys, you can see that this triangle here is the one with the most, so we will start here and we can work our way towards whatever we need. So that is essentially the story, and then of course we then answer the questions accordingly. So just 3 steps here. We then answer questions accordingly. Of course, we know that when we do solutions, 3-step approach. Anyway, anyhow, you guys already know what this is. So these are usually the 3 little steps that you want to think of when dealing with this question. They are very nice. Okay, good. Now let's start. 8.1 says, calculate the length of AC. Can you see? We want this side. Can you see? It's already pointing us in that triangle. So we can simply say the distance between the observer at A and the foot of the building. So that's good. So in triangle ACD. This is the best to start with, and of course this could have been made a 9-mark question. Just say do this, and this one is not given. So you see, in the finals the examiners are usually friendly. I'm a mean guy. From a lot of teaching and practicing, guys, I can easily link these two and you find out how you're going to start. You start here, you find the common side, you work towards this common side. Then from this common side you work towards this CE. Then from CE you can then work out that DE, because the question says how far is E from the top of the building, so to speak. So this is what I would do, but anyway, let's leave it for later. Now in this triangle, this is a right angled triangle. This angle is given, that side is given. We want this. So this is 10. 10 of, what is this angle? It's called, okay, let's not say a lot. We can just say CAD. Coronary artery disease. It's going to be the opposite side, CD, over the adjacent, which is AC. This is just using trigonometry. So this implies that 10 of 46.85 degrees is going to be 16 divided by AC. So obviously this is over 1, then we cross multiply. This implies that AC, when we perform our gymnastics, is going to be 16 times 1 divided by 10, 46.85 degrees. Therefore our AC is, so this is 16 divided by 10, 46.85. So this is effectively 15 units. So this one, 15.00, we don't need to do it. So it's not necessary to do 2 decimal places. So we can just say 15. But now this is meters, okay? Because that is 16 meters over a ratio which does not have a unit. So the unit that prevails is 15 meters. That's number 1. Oh, that's the answer actually. All right. So what is important is to have the unit of measurement considered. So substitutions, answer. Easy 2 marks. This could have been left to your own devices, right? It could have been left to to your own devices to find your way around, but it's good. Oh, yeah, actually it's 4 steps now. You answer the thing is last, guys. So firstly, if you did not have a leading question like that, so maybe we can say this is the 4th point. The 3rd point, we work towards the common side. So that's what we do. This is when this question is made as heavy as I would rather they did. But yeah, guys, we can't punish you in the finals, you know, we can't. So essentially, guys, we have this side. Now all we want is the common side again. So can you see? We want the common side now. And in this triangle, we only have this angle here. So these 2 sides include that angle. This is the opposite side. So we can set up a cosine rule. In triangle ABC, we know that basically AB squared is going to be equal to AC squared plus BC squared minus 2 times AC times BC times the cos of, what is that angle called? BCA. Okay, this is nothing but the cosine rule. Okay, easy in this triangle. Now we substitute. This is the best approach, by the way. So this is 19 squared is going to be equal to AC. We found it to be 15 squared plus BC squared is what we want, times 2 into AC. This is 15 into BC times cos of that angle. This is 105,61 degrees. All right, okay, all right. We sort it out. Going to 19 squared in back. I don't remember, guys. 19 squared is 361. Okay. Equals, this is 225 plus BC squared minus 15 by 2. This is 30 BC cos of 105,61 degrees. Okay. Let's clean it up a bit. This implies, in fact, we can make this a quadratic because we can see this becomes a quadratic. BC squared minus 30 BC. Wait. This doesn't come out like that. So we need to sort out that whole thing. So we just have 30 into cos of 105,61. Okay, we need to sort out that one. So we may have to protect our answer. This is minus 8,073 to 3 decimal places. To protect our answer, this is going to be times BC. Now this is going to be minus, because when we transpose this to this side, 225 minus 361 gives us minus 136. Okay, obviously we have something strange in between. We won't even think about it. We use our quadratic, so this is going to be minus into minus 8,073 plus or minus the square root of minus 8,073 all squared minus 4 into 1 into minus 136 all divided by 2 into 1. Therefore BC is, Now remember, this has to be a length, so we can't have a negative answer. So we have minus into minus 8, comma, 0.73 plus the square root of minus 8, comma, 0.73 squared minus 4 into 1 into minus 136 divided by 2. This one gives us a positive answer, and that should be the best one. 16, comma, 377 meters. Remember, this is an intermediate answer. We are not yet done. So this one step only got us that BC. We can say here also, what do we know? We know that, guys, also in triangle, say C, okay, B, C, E. What do we see there? We need that angle, because that one is easy. So we know that angle BEC plus angle B, or they call it DEB, is going to be equal to 180 degrees. This is the sum of angles on a straight line. Okay, great. So this implies that BEC, we're interested in that angle, plus this one was 122 degrees equals 180. Therefore, BEC is going to be equal to 58 degrees. So very important, né? Very important. So can you see? Be methodical. Don't just jump and assume someone follows you. You do it, you do it, you do it. Now, we can say the other thing, we're interested in this side now. Okay? Because that side will help us to work our way around. So we know that once we have the angle, we can set up a trig ratio. We've got the angle, we've got the side opposite, we're interested in the adjacent. So we can just write here tan of this angle BEC is going to be equal to the opposite side, which is BC, over adjacent, which is EC. Now, this implies that we've got tan of this angle 58 degrees is going to be equal to 16,377 divided by EC. Now that is over 1. You can cross multiply and sort it out. So when we sort this out, what do we get? We find that basically EC is going to be 16,377 divided by the tangent of 58. So this gives us a 10,233 meters. Okay, very important. Okay, now we can take it further. 7 marks, most likely 3 steps. Now we have that one. We've got that one. We can say then we can appreciate. Oh, right, this one looks strange. We can say then we know that essentially EC plus DE, or we can even say ED if we like, should give us CD. this is evident. So this is 10,233 plus ED, which is what we want, is equal to 16. Say therefore ED is going to be 16 minus 10,233, which is that one, Okay, we take this from 16. Right, so 16 minus 10,233. All right, so we get 5,77. Remember, this is to 2 decimal places, unless otherwise stated in meters. Okay, now how do we answer the question? You can say, therefore, the painter is at 5,77 meters from the top of the building. Okay, easy. Try to answer the question at the end. Do your own creations, but answer the question. Nice and easy. All right, guys, so 3 steps is pretty valid for such a question. The last one is weak, so the heavy ones are those 2, and rightly so. Okay, all right, okay. So what are we going to say, folks? Substituting into the cosine rule that we derived is beautiful. And I would say into this and getting that, maybe having 3 marks should be okay there. Then we come in here, we needed to find this angle. It's a mark, that's the 4th mark. And then we're getting the 5th mark here, and then the 6th mark. Yikes. This is the 6th mark. Do we really get a mark for this? Akitsebi. Yeah. Now I'm feeling a bit whacked. Yeah, guys, whatever. We can give a mark here if we like. So that is 7 marks. Nice and easy. So for a total of 9 marks in this heavy question. Okay, this one was a bit heavy. It's usually very heavy. Okay, guys, so we are going to go into Euclidean geometry. So let me just take a tea break, Nyana. I'm feeling a bit tired and refresh, and we come back. All right, guys, I am back. Let us get to question 9. Okay, not doing badly, but we're not as fast as we should be. So let's do question 9. Okay, now this is my favorite section, where we portray our charisma. Now in the diagram, ABCD is a cyclic quadrilateral, and BC is produced. Once you see that word produced, it means it forms a straight line. Okay, and then AC is drawn. Okay, that's also a straight line. And then what are we told? We're told also that angle A1 is equal to half of AB. So this we can interpret and say 2 times angle A1 is literally equal to angle B. That is the best way, because that way is crazy. Anyway, sometimes take liberty to interpret some of the information that is given. Then A2 is 46 degrees and C1 is 86 degrees. So what do we see here, guys? So what we say, it's this cyclic quad, and this side being produced to E provides us this parameter, that this angle must be equal to that angle. Okay, so we can see that both A1 and A2 should be equal to angle C1. That's the exterior angle of a cyclic quad. Right. So that's about what we can do. And of course, this can help us to find angle A1. Then that can also help us to find angle B, right? So it says calculate with reasons the value of angle A1. So 9.1. We know that angle A1 plus angle A2 should be equal to angle C1. This is the exterior angle of a cyclic quad. Okay, so this implies that angle A1 plus 46 degrees is going to be equal to 86 degrees. Therefore, angle A1 is going to be 86 degrees minus 40. So 6 and 6 go out to left 0, 4. 8 minus 4 is going to be 40 degrees. Nice and easy. So the mark is over there and over there. 9.2 says, hence prove that AD is equal to DC. So this is equal to that. Is it so indeed? Well, for this to be the case, we know that we need to find that that angle is equal to that angle. Because in this triangle, that would be the base angles of that triangle, or the so-called angles opposite equal sides, or we can even say these are chords. So equal chords subtend equal angles at circumference, since we have a circle there. So we need to find basically C2 is equal to A1. That's what we need. Now, if you look at this, so if we look at this yellow triangle, what can we appreciate, guys? We know that this whole angle out here is an exterior angle of this triangle. And this is going to include angle B, which we can use that property, and angle angle A2. And that C2 will come out just right. Okay, so let's have a look and see. Now we can say safely, in triangle ABC, what we can see is that essentially we want C2, so we know that angle C1 plus angle C2 should be equal to angle A2 plus angle B. This is the exterior angle of a triangle. This is the one we are talking about. Okay, we go on and say angle C1 is what we know is 86 degrees plus angle C2 equals angle A2, which is 46 degrees, plus angle B. Now we can see that angle B is basically 2 times angle A1. Okay, given that angle A1 is equal to a half of angle B. So this is what we are doing right there. In fact, I don't think we need to write that angle like that. We just substitute straight away. We got 40 degrees here. Okay, that's it. So therefore angle C2 is equal to, now this is 80, so when we bring in this one we get minus 6, so 46 minus 6 is 40 degrees. Therefore angle C2 is equal to angle A1. Each, maybe let's leave it at a reason, say each equals 40 degrees. Now, what do we need to do? We can make a conclusion that therefore indeed AD must be equal to DC, right? You can say these are the sides opposite sides opposite sides opposite equal angles in triangle ACD. So we need to be specific because we didn't talk about it. So a bit of integration there. Simultaneous equations sort of, where we used another equation to sort it out, but we used a smart technique just to make it a reason than to make this long and tiring. Now, now what we need, guys, is this reason. Very important to find out that this is so very important. This substitution here, key, and the first statement with its reason gives us those 4 marks, and we take those easy 6 marks. Again, this is just to break the ice so that you can feel like, okay, Euclidean geometry, I have landed. Maybe there are stones ahead, maybe no, we don't know, but we'll see. Now let's do question 10. Okay, question 10 says we need, okay, in the diagram, triangle RST is drawn. Line AB intersects RS and KT at A and B respectively, such that AB is parallel to ST. So this is good. Now what do we do here? Well, the constructions that we need to do is this one. We join this, obviously, but any construction we make must be dotted. Okay. Secondly, what we need to do is this construction also. We join those two. Again, like any other construction, must be like so. Great. Now, we can do a perpendicular height. Okay, does it look perpendicular? Maybe, maybe not, doesn't matter. We can make it look like it is indeed, and then we can join this. I don't know, it refuses to reach from here. Okay guys, doesn't look exactly perpendicular, but I'm gonna make it look like it. Again, these are constructions, so we break them up nicely. Okay, so this is the height. Okay, and that must be the height. Okay, good. So now, what are we going to do? Well, we know, guys, something that the altitudes of a triangle intersect at a common point. This is called an orthocenter. This is issues of concurrency. Now, what do we say? Concurrency, of course, it's when we draw another line which is going to be perpendicular to this side. You see, those altitudes definitely intersect at that point. So we call it an orthocenter. Very important piece of information, because in analytical geometry, this can be given indirectly, or even in Euclidean geometry, can be told that a particular point is an orthocenter, but perhaps you would just be given one line with a point or 2 lines with a point, and it simply means those 2 lines are perpendicular to the opposite sides of those triangles. So again, that is just me trying to give you an idea. So concurrency, simply is a point of intersection of 3 lines or more, because when it is just 2 lines we say it's a point of intersection only, but when there's 3 or more we say it's a point of concurrency. And when we name it, we are referring to those lines being those essentially altitudes. So this is very important, something to keep in mind. Okay, now what are we supposed to do? Well, this is what we need to do now. So what needs to happen here, we need to compare this triangle and that triangle. Okay, so this is based on some property or theorem, if you think about it, from grade 9. When we say 2 triangles, the ratio of their areas, when they have the common height or the same height, it will essentially be just the ratio of their bases. So we can call this height h, and then we can call this other height k. So this is what we do. So obviously, guys, we are going to say given, so 10.1, we know that we are given triangle RST with AB parallel to ST. That's it. Required to prove, so we call it RTP. We are supposed to prove that RA over AS is equal to RB over BT. Okay, this again I'm doing for the grade 11s who are going into matric right now, so that you can see how important it is to do these proofs with understanding, so that you don't forget and you never have to cram these literally. But again, if it goes to a push and shove, you can, because they are there in the textbooks. Now we know that we need to provide some construction statement. So this is key because we get marks. So what do we construct? Just say join SB and AT. We can also say draw perpendicular heights H and K. This is it. So we go into the proof. Of course, guys, pay attention to the method presented. It is very important. Again, this is key. So now we're going to compare those 2 triangles. We can say the area of triangle RAB divided by the area of triangle ABS. This is going to be equal to half times the base, which is RA, times the perpendicular height, which is going to be H, divided by half. The base now becomes AS times the perpendicular height, which is H. Remember, this is a scaling triangle or obtuse angled triangle. So the height, if this is the base, is going to be outside this triangle. Okay, great. So that's what we say here. And then what do we see, guys? We can see that half is the same as half, H is the same as H. So those two take each other out. We remain with RA over AS. Again, you can see that that theorem holds true, that the ratio of the areas of 2 triangles that have the same height is essentially the ratio of their bases, because this is what comes out. Grade 9 stuff. We can say likewise maybe we can say also, it's not a big deal. Also, the area of triangle RAB, again, over the area of triangle. Now this is the triangle we need to compare this to. Okay, so guys, the other triangle is this one that I outlined, pink or orange, whatever this color is. So this is basically ABT. Okay, this is going to be equal to half. The base of that one is going to be RB this time, times the perpendicular height, which is this time K, all divided by half. The base this time is going to be BT times the perpendicular height K. Again, we'll appreciate that the half does what it does best and the K's do what they do best, and we get RB over BT. Okay, so you can also appreciate here that the same happens here. When we look at these two triangles in terms of the same height K, we will see that the ratio of their area or area would be essentially the ratio of their bases because they have the same height. Easy stuff. Now we've got a story here to tell that, but we know that essentially area of triangle ABS is supposed to be equal to the area of triangle ABT. Why do we know this? We can appreciate that if you look at these two triangles, this one and this one, they have the same base AB. And if we were to draw a height to any one of these two sides, okay, we can do it here. It's not a big deal. What you will appreciate is that this particular height that we just drew is essentially reaching this line here, which is at the same level of those two vertices T and S. So even if we were to do it outside or over there, it would still be the same thing. So the perpendicular distance between the parallel lines would make us the base, the height of these triangles. So they have the same base and the same height, and therefore these two should be equal. So we can just simply say here they've got the same base, which is AT, AB, and same height between parallel lines. Okay, that's the reason for that. So if two triangles have the same base and they have the same height, therefore their areas are equal. But notice something, RAB is still same RAB. So we've got a situation where the numerators are the same, and we're literally saying the denominators are also the same, therefore. Okay, so what are we suggesting? This implies that basically area of triangle RAB over area of triangle ABS should be equal to the area of triangle RAB. So same numerator and this denominator now. So this is following from that statement and noticing that those two are the same. What can we say now? We can say therefore, what was this ratio? It's RA over AS. This is equal to, that ratio came out as RB over BT. Alright, so the proof is done, guys. Nice and sweet. So this is not a very complicated proof, but a bit scary sometimes. But if you understand the theory behind it, it's easy to manufacture. Alright, so this is easy, 6 marks. It's in the textbooks. I'm not going to bother telling you where the marks are. We just go on to answer the next questions. But I'd rather we leave this one and go on to the next question, the next page. So this is 10.2 over here, because that was 10.1, okay? Now 10.2, we've got an opening statement. We are told here, in the diagram, O is the center of the circle, okay? We can see it. And then triangle PWS, once this is triangle, it's suggesting that these are all straight lines. PWS is drawn, okay? Okay, so we see that this triangle is drawn, okay? So suggesting these are straight lines, and this becomes the diameter, so that this side is equal to that side. Maybe let's use the black color. Black like me, these are ready. And we know that the angle subtended by the diameter should be a right angle. Okay, so that is essentially what is being given to us. Now notice this is already given as 90 degrees, because we are told here that PW and S on the circle, so these are concyclic. OR is perpendicular to PS. So now can you see corresponding angles are equal? This is suggesting these two lines are parallel. Okay. The other thing is that a line drawn from the center perpendicular to the chord PS should bisect the chord. Okay, it's not so visible because of the shadow there. So that is the story. So can you see, guys, this is nothing but proportionality theorem, and more specifically midpoint theorem, because if the line is parallel to this side and it cuts the midpoints of these ones, so it means OP should be half of WS. So the midpoint theorem here is being given to us indirectly. So now it says PRS is produced to T. PRS is produced to T. So once something is produced, what do we know? It forms a straight line. Okay, good. This is to say this is a straight line. Now SW at OT intersect at V, so we get a vertically opposite situation there. And we are given more, that OV is to OT. OV is to, maybe let's do it maybe a bit outer. OV is to OT. This is 1 is to 4, so we can say this is A, this becomes 4A. Okay, we always choose a multiple. Okay, it's a bit dark now, let me just put some lights on. Okay, so this is what we have, guys. So this is literally what we can appreciate from what we are given. So let's move on. What do we see? Well, we need to answer some questions, right? Right, so 10.2.1. We need to prove with reasons that OR is to WS. Can you see OR is to WS is 1 is to 2, 5 marks. So we already did all the groundwork, so this is how we're going to start. We will say, without a shadow of doubt, that essentially we know that OP or PO, maybe let's start speaking about a particular triangle. In triangle PWS, we know that PO is equal to OW. Now these are ready. Okay, or radii, if you will. Number two, we will see that essentially also we know that PR is equal to RS. This is line from center perpendicular to chord. Actually bisects the chord. Now, we've got a situation now, essentially. Now, this situation is suggesting something very special. From here, we can deduce that this line is parallel to the other and ignore the corresponding angles. So, however we really see this, guys, is up to us. But I think since we've set it up like that, we can essentially conclude that OR must be parallel to WS. Okay, that should be the idea. So we can say this therefore implies that essentially OR is parallel to WS. Okay, now what are we going to say? This is the midpoint theorem of triangles. Great. So of course, if we've got a line joining two midpoints of the opposite sides, that line should be parallel to the third side. No questions about it, even if we ignored the corresponding angles. And then from here, guys, what are we going to say? If this is the case, it proves for us that OR over WS should be equal to 1. Oh no, let's put it this way. We know that OR must be half of WS. Again, same reason. If we said midpoint theorem, this is the deduction. So we don't really need to finish a reason because we've said it already. So all we need to do now is to show that indeed we want to show this ratio. So all we do, logically, we can divide by WS throughout such that we get OR over WS is going to be basically a half, because the WS will cancel out there. Therefore, we can write it the way it's given, that OR is to WS should be 1:2. Done. Okay, there's many ways of killing a cat. Kill it. Okay, that's the idea. Just murder it. That's a mark. Very powerful statement. That's another mark. Powerful statement. Good deduction. And obviously, guys, this was already volunteered, so maybe that would be good. So we can say 5 marks nicely. Everything is getting a mark. Again, it depends on the approach chosen. So let's do 10.2.2. Hey, come on, man. Ay, one dinner winner. One dinner gabi, man. Calculate the length of PT if ST is 15 minutes. So we know that this is 15 units. Okay, so this one is 15 units, so we need to do it. That is what we have over there. Okay, but what can we appreciate, guys? Since we've spoken about this, so this is PT, we want this whole side. We want that whole side. Okay, good. Now we've got this little piece inside, but this can help us essentially. If we look at this ratio, we can even look at this ratio too. It should give us the same ratio, right? Because no. No. So we can look at this ratio. Maybe let's just remove this. It's gonna mess up things. So we know that we want this ratio also over that one. Okay, so maybe let's take this one out so that we don't have a confusion of colors here. So this is what we want. We want that one. Okay, so what are we going to do, guys? Look at this. So can you see, guys, if we look at this smaller piece of the triangle, we've got the proportionality theorem there. So we can use that ratio for this situation and work out RS. And then from RS, we double that to get PS. And then we add this to get the whole of PT. So this is easy. So what we're going to say, we will say safely in triangle. We can say ORT. Okay, what are we going to say there? Now we're going to say something very nice. We want RS, so we can say RS over RT must be the same as OV over OT. Okay, now what is this? This is the prop theorem with essentially SV parallel to OR. Nice and easy. We've already spoken about that parallelity above, so we can use it now without justifying it. So what do we see, guys? We were told that OV over OT is a half, so we can say therefore RS over RT is basically a quarter. Sorry. Nice and easy. So we can just write it as it is, or you can choose to write A over 4A. It simplifies to a quarter. Not a big deal here. So we are fine. Now, what are we going to do next? Then we understand that we've got ST somewhere, but we've got a situation RT. Actually, let me not say therefore, because that's not conclusive. So this implies now RS is something that we actually are interested in over. Now we will have RT. I'm trying to think, hey? I'm trying to think now. It's not a big deal. We can sort it out easily. So RS over RT. So RT is nothing but RS plus ST, which is 15, equals 1 over 4. Okay, so favorite gymnastic, cross multiplication. Then what do we end up with? So we end up with 4RS equaling just RS plus 15. So we transpose the RS to the other side, we get 3RS is equal to 15. We divide by 3. What do we get? RS is equal to 15 divided by 3. This is 5 units. Okay, so now we are good because we got RS nicely. So we can then calculate PT. We can say then we know that then PT is nothing but equal to PS plus ST. This is evident. This implies that PT is going to be, PS is basically 2 times RS plus ST. You can see that this came from essentially PR equaling RS. Not a problem. So we can now substitute and say PT is equal to 2 times 5 plus 15. Therefore PT, this is 10 plus 15, that is 25 units. Nice and easy. Okay guys, there's a hailstorm going on outside. Is it a hailstorm? No. Thunderstorm. But I love the fact that it's raining, folks. Yo, I love the rain. Now we've sorted that question nicely. So obviously guys, this is a powerful statement. Nicely so. So the other important statement here, I would mark the substitutions. It looks important. Yikes. This RS is key. Okay. And then of course the final answer. This story right here is pretty straightforward, I suppose. But again, this one could be given a mark, especially in this segment right here. So it will depend on the marking guidelines formally. If this step is featured, of course, or this technique is featured, or this approach, then we can see how the marks are to be distributed there. So our final answer gives us our final mark for this question, which is a total of 15 marks. So pretty easy guys, pretty easy. Now let's get to the last question quickly. Hope I'll be able to finish in time. Question 11. Yo, the raining though is scary. Anyway guys, let's in the diagram A, B, G and F lie on the larger circle. So these points are concyclic. Okay, if they are concyclic, it means properties of a cyclic quad. When we have a combination of 4 and they are 4, maybe we can think of properties of a cyclic quad. Now a smaller circle is drawn to touch, it's a tangent, to touch the larger circle internally. So they are tangents to each other and we can see that. And then EA is the common tangent. Great. So nice and easy. So I like to highlight things, but sometimes they are not straight lines, so it embarrasses me at times. That's the common tangent there. We can appreciate that. And then we're told EBCF is a tangent to the smaller circle at C. So we've got another tangent, so I just hope it's a straight line. Okay, it is not so bad. And of course they come together at that point. Now we've got 2 tangents, and then of course we know that this segment AE is going to be equal to BC, right? Because these are tangents from the same point outside to the smaller circle. Then beyond this, it's not the case. Be very careful. But this is something to consider. Okay? Now, what do we need to say? We need to say something more. We are told here that essentially AC is produced to G. Once we see something produced, it's a straight line. AF cuts the smaller circle at D. If it cuts, it's a second. Again, a straight line. A, B, C, D, and G, F are drawn. Again, straight lines. Okay? So all of these are suggesting we've got straight lines. So understand every little piece of information given when practicing, of course. But when doing an exam, just know it as you read, okay? But sometimes it helps to highlight them because you don't forget. So Euclidean geometry is something that demands a little bit more focus because it can get ugly quickly, pretty quickly. All right, guys, so what can we do with all of this? Well, we know that these two, seeing that these points are concyclic, so these two must be equal. These are angles in the same segment subtended by chord AF or the arc AF. But now let's highlight something about a segment. What is a segment when we're talking circles? Let's say we've got this chord right there. So this chord cuts this circle into this segment. Now when we talk of a segment, this is not a sector. So this is the area of the circle between the circumference and the chord. Okay, that's a segment. Okay, we call this one, because this is the smaller one of the two, so we call this one the minor segment. Be very careful, it is not about the circumference. This portion of the circumference, we call it the minor arch. Or the minor arc. Please familiarize yourselves with these kinds of terminologies. And then of course this means this bigger one right there sendiqhela kabi wena funa uyenza ezomqala akho inhloko yakho yegusha eqinile. Damn it. So you can see, guys, that this one becomes the bigger one. So the area between the chord and the circumference is a segment. Now this is the bigger one. We call it the major segment. And this circumference, this portion of the circumference, is the major arc. Okay, please know these terms or these terminologies, because I have seen and witnessed some serious misconceptions, you know, by certain individuals when looking at this, and this can be very bad. Now let's look. Let's say we've got an angle subtended by that chord right over there. That same chord subtends another angle right over there, like that. So what are we saying here, guys? We are saying this angle over here must be equal to that angle over there. All right? The reason is these are angles in the same segment. Can you see? Same segment, subtended by either this arc or that chord. But they are in the same segment, meaning this area of the circle between the chord and that major arc. Okay, so the same can be said if we can draw these angles on the other side and look at them. Or even if we consider these two little small ones, if we consider this arch, can you see? This is what this means. So please understand what we mean when we say segment in a circle. It's not just the arch that we're talking about. No, we're not talking about the arch, but the area, because it can be anywhere in there. So please, that needs to be clear. Now what is the other thing that we know? Of course, guys, we know that this angle should be equal to that angle in the bigger circle. Okay? Why? Because this is the angle between the tangent and the chord AB, and that chord subtends this angle at circumference, okay? Or the alternate segment, we say. Okay? Now that is good. As you can see what we mean by segments, now you understand this theorem. Sometimes it is misunderstood, also this one, especially the wording. be careful. Say the angle subtended between the chord and the tangent to the circle is going to be equal to the angle subtended in the alternate segment. That's what we mean. Okay, that's the idea. And now you know what a segment is, so you will not be messing around. All right, okay, all right. So what else can we say, guys? We have a big story. We know that this angle here, A1 and A2 must be equal to that angle, D1. This is again the 10 chord theorem in the smaller circle, with the chord being AC and the tangent EA. But that very same angle, considering this chord AG, subtends this angle right here. Okay, so always, guys, try to annotate this cleanly so that you can see. Don't make it dirty. Colored pencils are better because you will get to see what you're doing without suffering. Now, can you see if two corresponding angles are equal, it already suggests that these lines must be parallel. Okay, this is good. Very important. Can you see we're really slowly working into our diagram to give us what we want? Okay, we are getting what we want. What else can we say? Sometimes you do more, sometimes you do less. This is usually enough, but let's have a look. That angle is equal to this angle. Okay, why? Look at this. This is the angle between the tangent and that chord AC, which subtends that angle. So this is the 10 chord theorem again. But this very same angle is vertically opposite that. So these are vertically opposite angles. Again, guys, once you see that your diagram is getting busy, you stop, okay? Because there's a lot to say still. But at this point, I think it's safe to stop before we mess it up, because you can also see C3 is going to be exactly equal to F2. These are alternate angles now that we know these two lines are parallel. But again, this is too much now. We can stop it. Again, we can appreciate that A2 is in the same segment as F2 subtended by arc BG. Can you see that? That also is what we just spoke about. So there's a whole lot of things to consider. But before we mess it up, we stop. Sorry. So let's start answering the questions. 11.1. We are told that if EAG, so this very angle is X. Okay? Determine with reasons 4 other angles that are equal to X. Can you see we've already discovered them in our parade? Can you see sometimes this can help? Sometimes it cannot, depends on how complex the question is. So this angle is equal to that, so that's the first. This one is equal to that first. Of course, 10 chord theorem in the two circles. And essentially, this angle is equal to that, 10 chord theorem in the smaller circle. That angle is equal to that, vertically opposite angles. So we've got 1, 2, 3, 4 angles. So we've got them. So we can start by saying, well, we know that angle D1 is going to be equal to angle, say, EAG, as it is given. So, of course, that is equal to X. So let's just do it. I don't like to write like this, equal to X. This is nothing but the 10 chord theorem, okay? Now we just keep listing them. No issues of trying to connect them again. So we can just say here, AFG is going to be equal to that angle EAG equal to X. This is again the 10 chord theorem that is in the bigger circle. So we've got two angles. Then again, we go on and say we appreciate that angle C1 is equal to angle D1. Therefore, since D1 is x, then that one is also going to be x. Now this is again 10-chord theorem. Guys, if you don't know the 10-chord theorem, quit maths. Don't do Euclidean geometry. It's gonna kill you, okay? C4 is basically equal to C1. Since C1 is x, that is also x. This is now vertically opposite angles. So all these things are at your disposal, guys. So we get 6 marks. So what can we say? This is maybe 2 marks. Powerful statement. This is again 2 marks. Powerful statement because these are 2 different circles. Then we look at this one. We can give it 1 mark because now it's getting old and tired. Right? Right. This one is not so big. Okay, that's fine. Not a big deal. But I think this tangent, because it's a new one, we can drop a mark elsewhere. And say this is from the same tangent, so we can leave it at 1 mark. But this is a new tangent that we're using. So maybe 2 marks and essentially 6 marks. However this is distributed, we don't care. At the moment, we just care about getting going. Okay. We need to prove that AG, where is AG? Now it's very important, guys, to be systematic. AG is this side over here times AD. Where is AD? AD is there, okay? Right, is equal to AC. Now AC is this side. So AC with CU is this side over AF, which is that whole side. So singafaka iphi laphana, the qanda box. Now we can appreciate that, guys, we are working on this triangle. So we can appreciate that, guys, we are working on that triangle. So our job is just to say these two are parallel, then we use our proportionality theorem. That's why we proved it above. So we can easily see that this in triangle AFG, what can we say? We can say easily, we appreciate that angle D1 is equal to angle AFG. Why do we know these ones? Well, they indirectly link through EAG, so we can just easily say each equals X above. All right, good. So this implies that essentially CD is parallel to GF or FG. Maybe let's try to be nice and sweet. As is Mali. Okay, so what is this? We know that corresponding angles are equal. So when corresponding angles, oh, what is that? Corresponding angles are equal. When the corresponding angles are equal, it means the lines are parallel that are involved. Okay, good. Now, what are we going to say? We can say then, we know that essentially AC, okay, maybe let's start with AG over, now it's going to be AG over AC should be equal to AF over AD. Okay, what is this? This is the prop theorem with CD parallel to FG. Okay, good stuff. And all we need to do now is just cross multiply and get it over and done with. So we can say therefore AG times AD is equal to AC times AF. Nice and sweet. All right. Okay. All right. We're getting 4 marks. Very interesting. But this one is key. That one is key. Okay, we can get a mark there. Almost 3 marks. Technically, I think, creating these is probably 2 marks. So these ones, the statement and its reason, maybe 2 marks. Okay. Now we can decide to give the mark here, or we can still give a mark there. It doesn't matter. But it is volunteered. This was not directly linked, so I think it's fair to give the 4 marks there. 11.3 says we need to check that these 2 situations here are similar. Okay, where are they? So guys, have a look at this. We're comparing the red big triangle and that yellow triangle there. So let's see. We can say in triangle AGF and triangle ABC. What can we say about those 2 triangles? First of all, we can see that these angles are equal, so we can just say G in the other one is equal to B2 in the other one. So these are angles in the same segment. Okay, nice. That's number 1. Number 2, we can see that A2 should be equal to F2. So we can start what are you doing when superb. We need to find a better way. A better way needs to be found. So we need to take this angle, link it to that one. And how do we link it? We link it through that angle, because those are corresponding angles. And we have already stated those. So what can we say? We will say, well, we know, actually we don't even need to say a lot. We know, we proved it above. So we're going to say basically angle AFG is equal to angle C1. Okay, now what are we going to say? H equal to X above. Can you see sometimes certain things become very nice indeed? Now once we prove 2 sets, the remaining set is going to be fine. This implies that essentially angle A3 should be equal to angle A2. This is what we call the remaining angles. Or some people say sum of 3 angles of a triangle, whatever you want to say. It's all easy. In our curriculum, if you just did those 2, you were done. You didn't need the third. But I seem to see this one feature a lot in your curriculum. So hey, if I feed you poison, there's no harm in getting the third angle, because you don't have to worry about it. So that is it, guys. So we can prove that indeed triangle AGF is indeed similar to triangle ABC. The issue here is that of AAA, the abdominal aortic aneurysm. Thetha ngazo zonke izinto. Okay guys, sigqibile. So this one is a mark. Again, we didn't really link these two, so that's fair. And sorting up the remaining ones, that's fair. One answer, that's fair. How would you get 4 marks if you didn't state this? We can get 2 marks for this, okay? Not a problem. Or 2 marks for the first, and then those 2 marks, that one and that one. Well, this is a pretty powerful statement, essentially, that warrants 2 marks for the statement and for the reason. Anyway, depends on also the marking guidelines. Now let's handle the last one, 11.4. Now, once you see this situation and you already know this is the suplex city, this is where you are going to get a German suplex and a whole lot more. So let's hope you don't break your spine and you don't cry. Can you see, guys, this question was easy to do. It didn't take a lot of time, even less than 20 minutes. Sometimes it can be very hectic. You find that you're doing 30 minutes on this question. But again, it depends. I mean, we've had stones throughout here and there. So I tried to explain so that you can follow. So I hope, guys, this whole exercise is meaningful. Anyway, let's finish up, guys. Let's finish up. So how do we start? I often ask my students that I teach physically, what is your plan? Because I know people always, cry when they see this kind of thing. So first of all, we're seeing GF squared. If this is squared, this means this could be a common side to two similar triangles, or just simply triangles. Because if the other one is right angled or any other means necessary, we can derive two simultaneous equations so that we can get a square. But this is the idea often present when we're looking at that. So let's look at GF. GF is part of the big triangle, but GF is part of this triangle as well. Let's stipulate instead of shading it. So this triangle, can you see that? So that triangle has this side, and it's like that. So very interesting. So what did we prove, guys? We proved that this A2 is equal to A3 somehow, and we can clearly see that A2 is equal to F2. Can you see this angle is equal to that? So this triangle is essentially similar to the bigger one. So we can look at those two maybe to get some idea about what is going on. So this is already suggesting some new similarity. Is it necessary? Is it really necessary? We can think about it, but this is the idea. This propagates. Maybe it can help us. Maybe it may not. We will see. We shall see. Okay, all right, okay, guys. So what I'm going to say now, we will say, okay, let's continue to check now. We've got BC. Where is BC? BC is on this side of this triangle. So we can see that, okay, this triangle is in here somewhere. ABC. And this triangle ABC can go. So that triangle ABC, we dealt with it above there. So this BC is probably coming from that triangle. We're still mapping our way forward now. We're not in a hurry for anything. We look at FC. Where is FC? FC is in there. Can you see? It's part of this triangle that we looked at with the common side. So it looks like this triangle is pretty much in here. It's pretty much in the game. So again, this speaks to this new similarity situation. Can you see? We are getting this idea, and this new similarity accommodates that FC as well as GF in a way. So the new similarity is also in there somewhere. Okay. Okay, all right, okay. So now where's AF? So AF technically is, maybe let's mark it blue. AF, we can see you, sir. This one is part of those big triangles. So again, this triangle is here somewhere, and AF was also there as well. So it means we could be using those similarities. Now it's getting complicated, but obviously when this is busy, it means we're probably looking at 3 steps usually of some sequences of simultaneous equations, and then we sort it up. Now Anno Domini, where is Anno Domini coming from? Yeah, when Anno Domini son uvelaphi kwedini ungasiqheli kabi. Asifuni uyaphi uvela khona thina, usijonge la way son, usijonge la way. So Anno Domini AD is coming from where? So we can see that this Anno Domini thing there is here, and it's also there. So hey, so guys, we can appreciate that there's a possibility of using this, that, and some new similarity, because there is some consistency in there. So how many similarities are we going to need? This, which is already there, we need to perhaps do something about that. That's the second. And this new similarity can give us some ratios. Then we try to work it out. So it looks like a plan. Of course, now this is one of those questions. When you answer these questions and you start here, it is going to potentially chow your time. So even if you think you have a plan, you can already see it's complicated. So if you don't trust your abilities here, you skip this question. You move on to the other bunch of questions. You see whether you have a plan, see if you can effect it nicely, and you do that. But the most important is make sure you understand if you have what is necessary right now, and do it right now, and make sure you use as much time as you can, because you can speed up on some easier questions to bank back that time. Okay, so ngunika kalo wena kalo mina man iqonda lento. So you keep doing it, because you can't just start from the start to the finish like I did. Of course you can if you're like me. I used to do that sometimes, but in the finals, guys, you don't want to make crazy mistakes, because that's your last chance, literally. Although you can do, the repetition. With us, you didn't have a repetition per se. You would mostly get a supplementary exam. If you failed maths, and since maths was a determining subject if you are doing it to pass, because if you failed maths, you failed the class, irrespective of whether you passed everything or you fail a home language, you fail the whole thing, So essentially what this meant was you would get a supplementary exam. So if you wrote in November and then you didn't do well, in February, March, you're writing the supplementary so that you can pass. That was all. You couldn't repeat metric like you guys can. You couldn't do it as many times as you wanted, and that was it. And I guess that's why we focused, guys. We knew there was no chance, and you guys, I relax a big time. Even though there's so much information available to you and there's so many chances available to you, you still guys fail, and because you're looking in the wrong places. Be very careful, be very selective on where you look at. In fact, at the end of this video, I'll try to plug you with some channels that I think, if you watch my channel religiously, if you're doing it religiously or because you're learning a lot, there are some channels that seem to do similar work in a similar manner as I do. Not exactly about everything, but I think if you combine their perspectives and their way of doing, it helps you to hear someone else suggesting the same thing or showing you a different way of just approaching the same thing you saw. And that way, I think you get to learn better. But again, don't just be a viewer. Don't be on the fence. Get involved. Get your hands dirty. Redo, like I'm going to do now. At the end of this, I'm gonna clean up all of these annotations and add this question paper to this document so that it's just one single document. Then I will put it in the description for you to download, and you can use it to practice, and again to use it as a template on how you answer questions in a convincing way, so that the person who's marking you even ends up giving you marks you don't deserve, because you just have a sweet way of presenting your answers, and they just are methodical and systematic and logical, and you know what, everything just says this person knows this. Even when the question's a bit unfair, they can just be a little lenient on you. You get your 100% even if you didn't get it, you know. Sometimes you never know how a good presentation, irrespective of whether it's on point or not, the fact that it is good, well constructed, well thought out, and carefully planned, and essentially exquisitely delivered, you would be given a serious round of applause, only later to realize, hey, this guy's talking gibberish, hey, watch out. But essentially you show a potential. You may even be hired for a job, because someone knows if we improve this person, we have a bomb. It explodes everywhere. Anyhow, so guys, it looks like we're in for some serious trouble. But I do want to entertain this idea of a new similarity, because I mean, I already have those two similarities. I don't have to worry about them. But I think the new similarity might help me. So I start here and say, well, in triangle, so we spotted it's going to be this and the big one. Is it so? Because this triangle is also similar to that. Should we compare this triangle to that? Then whatever we have here, we compare it to that, like we could here. Is it possible if we do that? Or we compare this big triangle, sorry, this small triangle with the big triangle? Because obviously, guys, it depends on how we see things, you know. Depends on how we see things. I'm not too sure what would be the best, but if we want this side, it's gonna give us AB, and we can find AB here, so that's good. Looks like we can win. And we're going to need that side CF, it's opposite this angle, and then it's going to be AC, and we can see that AC is in here somewhere, so we can get it if we want. Yeah, looks like it. You see, it looks like it. And maybe we might just have a final finish by using these two to get something else and sort this out. So I don't know, guys, it depends on the plan, but I don't want a plan that is going to fail. That's just one thing I don't like. But in any case, in this similarity, I've got GF. I can get it. Then in this 2, I will still have GF. So I can get it to square somehow. So let's try that. Let's compare these two and see what we can do about them. So we can say in triangle, we might want to start with this one, CFG. And triangle ABC. Of course, guys, trial and error. Sometimes you may feel that, okay, maybe the best would have been these two. It doesn't matter. Sometimes they're giving us the same result. So we should arrive at the same answer if we do everything well, of course. Now, what are we going to say? Well, we compare them. We've already compared this angle and that angle, so we can use that nicely. So we know that G is equal to B2. We can just simply say proved above. This time we don't need to say angles in the same segment, we just say proved above. And what we can say here also, we know that these two angles, F2 is equal to A2. Again, what did we see? Did we use it or did we say it? Agates. We didn't say it. We did not say it. Now we must say it. Okay, all right, okay. We didn't say it. Therefore, we must who can say it. We must who can say it if there's such a thing. Okay, this is going to be again angles in the same segment, subtended by arch BC or arc BC. BG. Nice and easy. So 2 ones, good enough, but we can even go for the other one and say, but we can choose to make it the remaining angle, but we've got them proved above. So in fact, let's not even write the also here. We just list them again and say, okay, we know that C4 is equal to C1, right? We saw that these two are each equal to X. Maybe we did not. We already proved above, so we don't need to write it. We proved it above. Can you see a whole lot of things have been done, so this becomes easier. So we can say this implies that triangle CFG is similar to triangle ABC because they are equiangular. Triple A. All right, okay, all right. So now what are we going to do, guys? We want FG or GF. So this also implies that GF, since it's part and parcel of this thing, divided by. Now GF is opposite that angle C4. The angle C4 is equal to C1. The side opposite C1 in that one is AB. So those are the ones that form a ratio. Okay, I don't even care how I named them. Just do it. The next one, what I want is that CF to come out. So it's going to be CF or FC as it's written, divided by. Now that CF or FC is opposite that angle. That angle is equal to that. The side opposite that is AC. Ooh, yeah, nah. This is the proportional sides of similar triangles. Now this is just coming out from these two that we compared. Now what can we say? We can say it like so. Do we want to leave it like this? Do we want to continue? I don't know. I don't care at this point because I've got AC, which I can find from this situation. I've got AB, which I can find from these two triangles that we worked with over there. So I don't know. Maybe we can rush and sort it out. Maybe we can delay this. It doesn't really matter. At this stage, we can just leave it there. Sometimes you need to be strategic, guys. Just jump around when you can. But now what I want gone, because here I've got BC. And I can get BC from here. And I can eliminate some AB because it's here. Even AC can come out here too if I want. But I need to be strategic in what I am going to do. We can say here, well, we know though, however, we know that however, guys, what we need to do, hey, I'm thinking, guys, though, there's so much to think about. There is so much to think about. Before we get too excited, anyway, we will see what we can do. So let's try to get something from here, right? Let's try to get something from here. Maybe we can deal with that later, or we can start there. It doesn't really matter because we've got AC that we can get rid of, and it gives us the AD that we want. Maybe we can say, but we know and understand that essentially, oh God, could we find AC? Because AF is there. Maybe let's say AC. We know and understand that essentially AG times AD is equal to AC times AF. I'm trying to think, guys, maybe this is not the best to do because I can still derive certain other ratios here that can suit the purpose of what I'm doing, you know. Yeah, I can try to get things my way here, you see. I can try. There's plenty of options here. CD, GF, you know, can do that. CD over GF is going to be equal to AD over AF. So that can also be used. But do I have CD elsewhere? Or DC? No, I don't have that. So now I don't want to introduce things that I don't have, so it doesn't look like it's going to work. Doesn't look like it's going to work. Can look at AG over CD. This one is not gonna do it. It's not gonna do it. Let's just leave it for now. Let's just work with this one. Sometimes you go into panic mode, of course. It's natural. So we don't want AC. Maybe we don't want AC. Maybe we don't want AG. Whichever we choose to write down should be fine. Okay, let's just deal with AC. See what happens. So essentially, guys, what are we trying to get is AC alone. I am trying to think though, is it fair to, maybe let's do AG. Let's just do AG so that this remains on the numerator. We don't want a situation that is out of control. We can say this implies that AG is going to be equal to AC times AF, all divided by AD. So I'm just trying to set up something like that. So we've got AF over AD. Maybe we can leave it. We can leave it there. This implies that this is when we divide by this, okay? Very easy. So what can we do now? We don't have AG here. So now this is already suggesting we need to find AG. Why did I look for AG though, guys? Why did I have to look for AG now? Esan. It looks like I'm digging myself a grave now. Why something so good is turning ugly now? Okay. I know I'm panicking. So it looks like we may have to reconsider our strategy. I hate it when it gets complicated. Now let's see, guys, when do we get AG? But can you see here, AG, if we sort it out up there, we can get it here as well. We can get AG here. We definitely can. Because we have not used this one. So yeah, we can get it there and see what happens, eh? Let's try and get it there and see what happens. But my worry though is AG doesn't feature here. So I don't know how we're going to manipulate the AG here, but we can essentially see what we can do. We can eliminate AG by introducing this. Maybe it's going to work out. Let's try. This is the one. We can say also, we know that in this similarity, we can see that AG becomes a friend to try and get rid of. At the same time, we want GF to come out. So we can start with GF and say GF over. Now here GF is in this triangle. It's opposite that angle. That angle is equal to that. The angle opposite that is BC. So over BC, is equal to. Now, what we want to use is what we have above somehow. Because all we need to eliminate is something that has AG in it. We must get AG to get out. So we can choose AG here. So this is this side right now. AG over. Now AG is opposite that angle. That angle is equal to that. And the side opposite that is AB. So that is the one. AB. So again, this is the proportional sides, similar triangles, in this time 11.3. So state exactly where you're getting this so that no one asks you what has happened. Maybe we can say proved above in 11.2. This is just trying to be as complete as possible. So now what do we get here? We can actually isolate but guys, it looks like this thing is going to backfire for me. The way I see it, AG here. Sorry, did I say GF? Yeah, anyway, BC is part of this, so I don't need to eliminate BC, so I should not worry about BC. All I worry about is AG and AB. And that is there, so I can deal with it, okay? Enough panicking. Now we can see we're going somewhere. So essentially, guys, we need to get rid of this AG guy. Even though I'm not too sure what is going to come of it, we can see that that is AG. Ne? Yeah. So let's see what we can do, guys. This implies that, of course, we do our gymnastics like as we would like to do. But now we want to get AG out. So this is going to be AG. It's going to be equal to AB times GF over BC. Zake ngiyibone ingathi ufuna ukungenzela imihlola. GF hamba no AB. This one goes with that, and then we divide by BC. Okay, maskesibona. Now these two are equal. So this implies that basically AC, okay, this implies that AB times GF over BC is going to be equal to that one, which is AC times AF over AD. Hey, ingathi funa ukusimosha wena. Oh, batla hore sinya wena. Empa fela itla sebetsa man, itla sebetsa. Now the guy that we need to become the subject now is AC, so that we can take everything back in there because there's no AC there. So if we continue doing our gymnastics here, hey guys, maths izodlala ngawe mawungayazi ngiyakutshela wena. So this step is becoming big. Now we cross multiply there, we want AC. We can say, maybe we can easily say therefore here AC is going to be equal to AD times GF times AB, okay, all over. So this one times that, then we divide by AF over BC, okay, or BC and AF. Okay, let's start with the way it is written. Okay, so we are getting somewhere. We're getting somewhere, guys. Now, what are we going to do? We can say then, this one is shaking me. We take this one now. This is the framework that we built. We take that one and try and work it out. So we're going to say then GF over AB is equal to FC from above over AC. Kuyona taba. Hayi ingathi izosipana guys. Sendiyayibona. So this implies now we've got GF over AB is equal to FC divided by, now AC instead we're going to write all of that, AD times GF times AB, all divided by BC times AF. Okay, all right, okay. Now this is looking good, so this implies that GF over AB is going to be equal to, now this one flips when we multiply by it, it's going to be FC, right, multiplied by, we flip this, it's going to be BC times AF, all divided by what is on top now. So this is going to be AD times GF times AB. Yay! Maths sanya methula. So this is GF over AB is equal to, now we have numerators multiply, so we end up with just BC times FC times AF. All of this divided by AD times GF times AB. Okay, good one. So now guys, we need to eliminate these ones from here. Oops. We need to eliminate these ones. So in mathematics, when we've got an equation, what we can do, we can just do what we call multiplying by what we want to eliminate. So all we do here, we just multiply by GF times AB. And what we do on the one side, we do on the other side as well. Maybe let's do it this way. So maybe let's write it differently so that you can see that this is now a gymnastic. I'm just tired of writing steps. Times AB. And we can do the same. GF times AB. Okay. Good one. And what do we see now? Simqhela kabi wena. Tlwaela hampe jwale. Tlwaela hampe jwale. So this one, we will see that, okay, these ones will do what they should be doing. Great stuff. These ones will do what they should be doing. These ones will do what they should be doing. You can say therefore GF squared. Those two must be equal to BC times FC times AF over AD. Yeah, this one was a proper anodomine. This one was a proper suplexity, guys. Yeah, you could see it too. I sweat. As you can appreciate, these are the questions you just don't want to answer early on. As you can see, this is a proper essay for just 6 marks. But again, how many steps? If we think about it, this is the first, maybe second, very long third step perhaps. Okay, maybe not long, but this is not even a step. We can say this is the first step. We can look at this as the second step because that's big. And then that is just a link of some kind, and then we substitute simultaneously for the final finish, and then we perform our logical gymnastics. I hardly use this technique, you know. I hardly use this technique, but you can see if it works, why not? Because the most important is to get the answer. Remember, you need to learn all the techniques in maths to appreciate this thing properly. Alright guys, so this is it. I don't know how to even mark this thing, but again guys, this was proved. So maybe the one that gets a mark is this, that one there, and this one here. Very important, because you can see this became our backbone for our solution. 2 marks. Second issue here, this would be the third perhaps, I get. But I think this one is too weak though, guys. It's too obvious. We already have it, so that's not impressive. So we've got 2 marks. But I do believe this is key. And if this is key, what did I do here? Why do I see things I don't understand now? What did I do here? I got AG. Okay, that's fine. Hey, why do I feel like I made a meal of a situation here now? What is going on here? I've got AG there. Okay. Now I just continued by taking that, which is here, and substituted in the space for AG. Okay, that is good. So I do think this is important. And this is important. So this is how many marks now? 1, 2, 3, 4, 5. Yeah, when then we got here and substituted one into the other, and when we did that, I think that is mark worthy. So guys, this is crazy, you know. Even this one can be considered for the mark, and as long as we get to the answer. But the answer was volunteered, so not a mark. So you can see here, the Kalintongala. Ile walapha fantat. Hayi ditsebetsa ka di bohloko ebile. Hobaneng a ntatemogolo. Ile wa nkotla ka nnete. Ile wa ngotla man. Hayi unkotlile ka nnete. So you can see, guys, these are not the questions to go and fool around on earlier, because you can see this one on its own took a lot of thinking. Sometimes you may not even finish, it's possible not to finish this question, because usually you won't have more than, say, 30 minutes, 45 minutes tops. You will hardly have more than those minutes left for you to do this. But again, if you banked your time nicely, so that this is probably one of the 2 last questions to do. You can see this took plus or minus 20 minutes. So you can say of those 45 minutes, the first 20 minutes you can do this, and then the remaining 25 minutes you can split into any other questions that you may have skipped. I mean, that can work. So it takes your courage and your resilience, honestly. Okay, folks, our 6 hours is over. I didn't think I was going to go this far, but hey, when maths is doing its own things, it just does its own things, okay? So guys, be on the lookout for this memorandum in the description, together with this question paper clean, as well as the answer sheet. So practice answering into this thing, because you might as well learn how to answer on this small space. But I feel this is absolutely ridiculous. But hey, I don't make the rules, but it's unfair. And we wonder why our kids don't do so well in numbers. There's so many chains put for them. And I mean, poor teaching, attending forever and never resting. They can never code that information, honestly. We forget the social networks also on this side doing their own damage. Teachers are obsessed with that too. They're not focusing on teaching quality. The books themselves, I mean, I've read a few of the recent textbooks. Sometimes I worry, who writes these books, Okay, I cannot fault all of them completely, but I mean, books of old, you will hardly find a mistake in those books. But our current books, there's so many mistakes you will see. Icon, you see. Then, guys, you come to the test, and then there's this nonsense here. This is like a ketang look rebel. Anyway, guys, let's take the last 4 minutes and plug you with the channels that I think you might want to have a look at to supplement what I do, because those channels, when I have looked at those videos from those channels, I can tell you they use a similar style, if not a better style than me. So you can learn even better from them, because some of them are teachers. Now, the first person that I want to, remember the order here, guys, doesn't matter. I'm not ranking anybody, but I'm just going to suggest channels that I would recommend you make sure they are part of your tools or arsenal in going to this war. The number 1 channel is Emmanuel Chauke. So Emmanuel Chauke is a mathematician. That's why he will provide you a better advantage than I would. He's a mathematician and a teacher, okay? So I think the guy has done his master's, if I'm not mistaken, but that's a guy who's properly qualified to teach maths, at least. So look at that guy when he does his work. You will appreciate it. So that's the channel you can look, and his techniques not that far off from mine, and that means you may get more in between, and each one complementing one another and so forth. The second person that you want to look at, who uses a similar style, is the queens. There's just maybe 3 queens that can teach you properly, like the real queens, because I mean, our mothers are the ones that nurtured us, and the ladies are the best to nurture the country mathematically, because they have logic, they have the patience, they have the ability naturally from their estrogen and all these other hormones, to really nurture, those that depend on them. So first one is Ntabiseng Maimela, if I'm not mistaken. Her channel is NTE, okay? Although she looks to have abandoned that channel because I don't see any new activity lately, but I'm happy though that kids are still finding the resource useful. You can see the views are growing. Everything is doing well. So I hope she comes back soon because she's very good. Her contributions are definitely necessary. So there you will learn a lot. Again, she uses more of a similar technique. She takes time to explain so you can follow. But again, those guys are more skilled. They even edit the videos so that even though they take a bit longer to explain and all that, they don't go all the way like me. They can edit those videos so that they are much shorter than mine. So that means, again, you can save your time there if you feel my videos are ridiculously long. But here, my intention is to build your endurance so that you can be able to concentrate for 3 hours in the exam and still be at your best at the end of that exam. That's my idea, because I saw how many crashed because of not building up endurance in terms of concentration, performance, and perfection. But you can look at those guys. They do edit their videos. I mean, I'm not computer literate, so I don't know how to do those things, and I'm not interested anyway. Now, let's have a look at the other one. The other queen that you can learn from is distance learning with Lee Lehlohonolo Sobing. She's very good. She's a teacher, I believe, and you can tell, man, this is a proper qualified teacher. She takes you from zero to hero, I can assure you. Although she likes this Maths Lit thing, she teaches it more. In fact, I have been amazed because I thought that Maths Lit thing is totally simple, and it's definitely not. And I've had to learn a few things, you know, sometimes you watch these, out of just interest, and then you start learning instead. Because I mean, when she taught this thing about rebates and, taxes and stuff, you know what? I got called recently to SARS telling me I'm owing them money. Like, hey, why is on guys? You did an auto assessment. You said I'm not owing. Where did the owing come from? Now, when I went to SARS, and they started talking about, interest from my savings account, and I'm like, hey, but even savings account Aibo SARS, come on, guys. This is my extra money that I'm taking from my salary that you already taxed people. Now I'm making a bit out of it. Now you want a piece of that too. Come on, guys. The taxman must just go away. Or else we're going to blow up those SARS offices. I am going to do it because I'm tired of me being punked. That means you work harder, you lose more money to SARS. And yet they're going to loot all of that money, those bloody politicians. So you're literally just wasting your time working hard. This is just what this translates to. I'm really unhappy with this. Because this guy should look at this. If I save into a bank or I invest into some bank product whatsoever, and I'm generating interest, remember the bank also makes money at the same time. And if the bank makes money, then the bank can fund small businesses. So I'm already contributing to society positively. Why are you punishing me? I don't get it. I really don't get the SARS thingy. Because if I make savings and make profits out of them and some investments, I'm not just making myself rich, I'm making the bank richer, and the bank can fund more people who need funding to start off their businesses or to sort up their lives by taking loans and all those things. I mean, this is what helps to keep the money in the country, and that means we are making the economy grow. Spare that there's a lot of nonsense going on with the banks and rigging things here to really loot our country in a way. But I mean, if I think about it that way, but again, I can be crazy. I may be missing the point, but I feel like the hardworking individual is being punished by SARS. For the rest of the lazy buggers around our country who hated school, didn't want to go to school, didn't want to even try, and yet now they are used as a bait for us to lose more from our hard work. as a facade that we're going to save. It's making noise, the TV now. So it's a facade now that we're saving the poor, but actually they're just enriching themselves more, because do they even pay taxes? You find them getting caught owing billions to their taxmen. So I mean, come on guys, why we the honest people are punished for this? I don't understand. Sometimes I really hate the way our governments work, because they were designed outside this country to not serve the purpose of these people. And of course, the hardworking citizens are usually less aware of financial literacy and understanding, like myself. I can count, questions on financial maths because it's just maths. But I don't know how these things really work in the real world. As you could see, I got surprised with a bill of 6,000 some change. Like, what? Come on, man, that could have bought my children, Christmas clothes. Now I had to lose it to the taxman, and he's saying to me, no, it's because of your savings from your savings account. When you get those profits over the year, we want a piece of that. I'm like, my God. I even said it to the official. Oh, in this country, definitely to have peace, you must just be poor and have nothing, because you have nothing to worry about. No SARS breathing down your neck and causing you more misery. Because you're working hard, but you're losing all of what you're earning. So basically, you're just working for peanuts, because remember, what remains is still going to be taxed when you buy items. You're paying VAT, and I'm like, so we pay tax forever, guys. This very salary that they bill a lot of tax from it. You then go on and you get taxed for profits when you save, you do investments, you buy items, petrol, there's a huge tax in there, food items, tax, clothing items, tax. Again, the cars, if you own a car, bloody traffic department wants money every year, like a huge amount of money. That's taxes in a way, if you think about it. You own a gun, they will tell you in 5 years time you need to renew the license. But why, man? You know how to shoot already. Come on. Why am I paying for what I already have mastered and perfected? Wasting my time. Again, it's a way of making money. Now they are introducing this new thing now that we need to have our ID cards instead of our ID booklets, because the booklet can last a period of many years. I mean, my booklet is as old as I am right now. Okay, maybe not necessarily as old as I am. I got it in 2005 when I was doing matric. So this is almost 20 years now. All right. So technically it's still well and fresh. Now they want us to change into ID cards. They're threatening that we're not going to get serviced anyway if we carry this. You know why? Because they want to make money every time we change those things. You know how those cards can be scratched on your wallet and stuff. So within a year, that thing is not working. So they want to generate more money. That is taxes if you think about it. Come on, guys. They're even taxing the poor people because those things are going to not work. And they will need to renew those things. I'm like, the brutality in this land, I cannot believe its extent. And yet they're not helping anyway in terms of the government. The government is literally failing in everything that they have started. It's really sad, guys. Okay, politics. Anyway, guys, we're done with the work, so I'm trying to just give you some extra pearls about life, because you need to know these things. You don't want to get surprised. You might as well develop tolerance over this nonsense, because it's not getting away. In fact, it's going to get worse. So you might as well not mind it, as long as you can buy bread and eat with sweet water or whatever, Kool-Aid or Sweet 8, drink or pop, whatever you call it. As long as you ate something, it's better than nothing, okay? And I'm like, guys. So the point I was getting to is that Lee's lessons, while I was watching out of interest, because my nieces were upgrading, doing this maths lit thing, and I told them to have a look. Now, out of interest, I ended up learning, because when I got to SARS, when they explained to me, I then understood all of these things about rebates, thresholds. If I get an increase, then I increase my threshold and all those kind of things, taxable income, you name them. I'm like, anyway, I understand it as unfair as it is. So thanks, Lee, for that, because, as much as I took that maths lit for granted, I actually learned something very valuable from it. So I think those lessons are necessary, truly, because they will enhance our literacy of all these issues that surround money and our responsibilities for the nation. So I do believe there has to be a way of incorporating it for all students, that maths lit thing, because it is definitely proving a bit more important, because nobody teaches us those things. So we get to learn them from school and then we become well aware early, and who knows, it gets better. So I do think, as much as I was negative about it initially, but I think it's good. In fact, there are some technical questions there that no easy, careless students can do it, and I then understand why those guys fail it. But again, go to Miss Lee, you will be the best. I wish she comes back to pure maths and maybe even add physics, because I would believe if she did maths, she should probably have done physics. You must add there your wisdoms, Lee. It's very important, guys. People like me are too busy. As you can see, I'm not posting as often as I can, and I can't actually. So you guys need to really do more and benefit more. Now, the last queen, what's the name of her channel? Math Truly. I think that's Math Truly. She's brilliant, guys. So go and have a look at most of her videos as well. She goes in depth in explaining and performance and everything. So she's not the person who just chases time, and so you can all come in and watch, but essentially you're not going to have enough time to assimilate, and therefore that's a futile exercise in my opinion. But again, it depends on who you are and what are your needs. Faster students, they just need to see the answers to see if they did it okay, or to see where they got stuck, but they understand the rest, so they are fit for those kinds of videos. But the majority, guys, we know they struggle, and we can push them to distinction candidates. And you have to have patience for these long videos to endure, so that you can become your absolute best. Okay, now those are the 3 queens I can give you. Now the third channel, the channel now, of course, guys, I'm not rating them in any way. There's nothing better than the other. They're all equally excellent. You can check out Bright Young Brains by Levi. Guys, very good. Again, I don't see most of his videos lately. I don't understand why. It goes back to the same thing I probably said before, that YouTube is seemingly capping our videos, because you start to see that around the exam time, you see students seeing these videos, because now they are coming through in numbers, but you don't see that YouTube is showing these. Even if you get 1,000 views, it sort of just gets stuck. You would expect that once it hits 1,000 views, it should be like a chain reaction, exponentially increasing in views, but it doesn't seem to be the case. I don't know why. But all I can say is that YouTube is somewhat capping our videos, and that is not right. Okay, just a moment. Okay, it's just the kids playing on the gate. Now, so Levi seemingly keeps changing his channel as well, because one moment you see he has very high subscriptions, and then the next you see he started it all over again and re-uploaded his videos. But again, support the guy, guys. Those are people, man, who have done a lot of work for a long time. You cannot have their channels sitting below 100,000 subscriptions and being the main channels going around, because those are very good people. Support even their businesses. Those guys have lessons that they do privately. They have courses you can buy online on their websites. Remember, guys, they may say 4,000 rands, or even say 1.5 per course for a period of time, and you cry about it and be like, yo, but that is expensive. But remember, guys, your parents are paying over 20,000 a month in school fees for you to be in the best schools. But guess what? All you get is just being pushed on a wheelbarrow so that they don't complain. The teaching, we know, even in private, is not as strong as it used to be. In fact, if we think about it constructively, we know that the DBE curriculum was actually stronger, although it is not rated as such. for particular reasons that I'm not going to go into, but it has never been weaker, the DBE to IEB. As I can tell you now, when we were matriculants, IEB question papers were more approachable and easier to answer in full without struggling compared to the DBE papers, and it still is the case right now. Yes, they have a different style of questioning here and there. There are some really tough questions, of course. It's not going to be entirely easy, but I can tell you the majority of questions, you can bank a lot of marks and get a decent pass there, and that's why they look better. But here, you seem to be given stones and very little when it comes to approachable and easy questions. Again, the straining in terms of the space to write and all those, you can easily see the IEB papers, there's ample space for you to write. You don't have the same in the DBE, which is crazy. Why is that? Don't know. Anyway, guys, yay, let's finish now. We were on Levi. So what I'm trying to say, guys, pay those 1.4s, 1.5s, 2 point some changes these guys require, because those guys are the best. They are teachers, some of them. Others have been teaching for a long time, so they know exactly the tricks and all the things that the examiners sometimes seem to have. Sometimes they even know the examiners themselves. So you have a huge advantage there for a very cheap 1.5. You can't buy a lot with that nowadays. Just get a pair of shoes and that's it. So guys, you might as well wear cheaper shoes and buy that thing, because then that gives you your dream car, it gives you your dream house, it gives you a dream career, and a very long, fulfilling life. Just for 1.5, if that is what it goes by. So don't always look for cheap, guys. Cheap things, you will get substandard materials, then you're just going to fail despite the help around you. Then you go and pay 20,000 to a very, very expensive tutoring program that doesn't change much from you, because they'll still be doing the bare minimum, to be honest. So let's not do it, guys. Support these dudes. Whether you support by making sure their channels are growing, give them likes, you give them views, because YouTube can pay them instead if you can't pay them yourself. Make sure you make those channels explode. I mean, mine, it's okay. I don't know if I can handle a number of students at once. I would go crazy. So I think the pace in which mine is growing is okay for me, because I can handle the requests, the questions, and everything, comments that I'm getting. So at least I can handle that. So I think it's okay for me, because my intention is just to add to what is already out there than to try and be the primary, individual. So who's the other one? I'm plugging you guys now. I'm taking time to plug you. So who's the other one? I don't want to forget Amin Hendricks. Muhammad Amin Hendricks. Guys from PE. Think NMMU, and he sounds like a true PhD mathematician, honestly speaking, guys. And those are the best lessons you can ever find for maths in this country. I have not seen any better. When I came across his channel, I can see it's as old as 2020, guys, and very good lessons that I've just had to look through sometimes, out of interest, of course, because I see some of my students who subscribe to me, they actually watch his channel. So I was like, come on, guys, why is this channel not exploding? It should be over 1 million subscriptions right now. And the guy also looks and seems to have abandoned that channel, because, honestly, guys, from 2020 to 2024, 4 years already, that channel has more or less the same number of total views as my channel, but mine is from 2021, and mine has been very slow in terms of growth, because I don't know how to edit, I don't know how to promote these things, and I'm not in all social platforms, social network platforms, which I'm never going to be anyway. Okay, maybe I'll try. Okay, just to try and help you out, guys. Okay, yeah, so please watch Mr. Amin Hendricks. In fact, if you want proper maths lessons that will build you to a very strong individual, I think he's outclassing everybody on YouTube, especially when it comes to our curriculum. Don't worry about outside curriculums, but our curriculum, that man is the best. So watch his lessons, do what he shows you there. You will be the best, okay? Who's the other one that I can plug you on? Virtual tutorship. Very good guy. Takes time to explain. He even gives a bit of vernacular there, so you can identify a lot with him and how he does his things. He's also very good. Again, his channel has been around from around 2020 as well. And you guys, please man, support these guys. They don't ask a lot from you. A like is free of charge. Subscription is free of charge. You know, viewing the videos enough to, you know, increase the views and stuff. It's also very free of charge. So guys, this is the least you can give back to the guys for the hard work they do, because some of them are students. In between the exams and studying, they give you something better. So stop squashing what makes you better, people, and start supporting what doesn't really make any difference in your lives, which is the nonsense in social media where you just chit-chat and gossip and what. And yet you bank a lot of data for that. And you cry about data for educational videos. Qabanga empama nini. Funa ndinyathele emqaleni. Futhi umtshana wami wenza umatric kulo nyaka. I hope ubukele wena mtshana ndizokubiza ngegama. Waqala nje wanixelela inyongo nje ukuthi uyafeyila ndinyathele emqaleni wena. You must watch these videos and the ones I'm talking about. Who else am I forgetting that you wouldn't know? Of course, I'm giving you guys that you don't normally think you would know. In fact, what I think you wouldn't really check out. I don't have to mention the popular ones because you already know them. So there's no missing them at all. Just giving you those ones that are low-key, strong individuals and that give you more value, actually, if you think about it, than the usual stuff. Not to say the usual stuff is not. I mean, I give the usual, but it's not as stale as you may look at it. It's not as bad as it is, isn't it? Yes, mine I know is very bad and it's usual for those who come through regularly. But it's not too bad. But I think the guys I mentioned are doing a lot better than me. Who else am I forgetting, guys? Oh, math and science. Is it math and science tutor? But you have those models of organic compounds as his, you know, logo. Math and science. I don't know. I think is it Folofelo Koza. I think so. Man, it's very good. Very good. And the one good thing about it, for those of you who are quick and want fast things, he's the fastest I've seen. The way he answers questions so quick, you cannot believe. Even before the memos come out, he already has a very fast approach to these questions. So you check out that channel, especially if you're speed oriented. You will learn there a lot because it takes time to explain and to provide you solutions. And for many videos, sometimes you get lessons, sometimes you get, you know, reviews and stuff. That's the guy. Of course, I see a lot of guys than the ladies. I don't know why. Where are you ladies? Where are you ladies? I mean, come on, guys. Stop doing TikTok and what do you call these things? The challenges. I mean, don't be there, man. Come here. Teach. Share your experiences in the positive way, man. Stop wasting time and money there and destroying our future even. Who else am I forgetting of? My top individuals. Okay, let me not say my top individuals. These are the good guys that are doing better than me in terms of what we are doing here. And if you check them out, you will learn more and better. Hi guys, there are just many guys anyway. There's new tutors as well that are very good, by the way, but they're still growing their channels, so you may not see them. Sometimes I forget their names because I often make a point that I watch videos and like those videos, even though I know I don't really need to learn that at all, just to support. So I do it all the time. That's why I get to know these guys. I also do this purposely to try and support those channels to grow, because I know that is the future of teaching, because I'm not going to do it anymore in the next few years. I'll be focused in growing my, you know, capital and growing money and, you know, building things for my family and for my society. And who knows, also improving things for my country at large. If I can make it there, we will see. So the teaching will have to be left in good hands. And so this guy is being supported now make sure that the future is safe. Oh, how can I forget Batande and Arti as well? Check that channel, guys. Oh, that guy does work. It does the Lord's work, believe me. The way he takes you through a question, you start to understand maths, even if you did not. Okay? Very good channel. Again, I'm happy now that it's growing. At first, I could see that all the efforts didn't seem to be reciprocated with growth. But I see those guys are growing now, and they're growing faster. In fact, I think very soon, in the next year, by the first quarter, they will have surpassed me. Definitely, they will have. So that's a very good channel. Look there. Again, you get physics, you get maths. So in-depth analysis and solutions there. So support, guys, support. And then, who did I think of now? And the name just disappeared now. Esan. Heban. I just thought of the name and now it's running away. Okay, guys, now I'm taking too long and wasting your time. But hey, if you want to learn and hear about this, you can do it. If you don't, thank you. Bye-bye. It's not bad. Hi, man, guys, there's someone I'm forgetting. There is someone I am forgetting. Hi, guys, there are too many, though. There are too many. Even the ones I did not mention, please support. If you see a video, even if it's a channel that has 12 subscribers, how can I forget, my friends? Oh, my Lord. MV Tutors. Now that's the one. I can tell that, hey, I'm forgetting very, very, very influential people. Very good, hardworking tutors there. An excellent analysis, excellent approach, excellent execution. You even get lessons, you can book lessons, you can, buy a whole lot of things. They have a website, so you can learn a lot from them. MV Tutors. So again, guys, support. That channel is excellent. So it must not be, where it is. It should be way ahead of me as well. Should be over 100,000 subscriptions right now. Please support, guys. Support local folks, because you will learn relevant things. Because as much as maths is wide, it's practiced slightly differently, although there's some commonalities elsewhere. In our setting, this is what is relevant, and this is what will improve your life. Because even if you go overseas after you qualify, you will fit in. You will not feel like you don't know enough. Believe me. It's all about you. It's not about what you received. If you grow it, you make sure you get it right, you will be able to transform and adapt to a new environment, okay? So yeah. So guys, there are too many tutors I see and support. And I pray that you all guys that I mentioned yourselves support these other guys as well, because they need to grow. Reality is we will not be around forever, all of us. We have a lot of reasons and responsibilities to worry about. So these young ones are still fresh, flexible. They have a lot of time. They are technologically oriented. So they can do many things at once, and therefore they stand a better chance to deliver this message of education in the sciences much better. So guys, I think so far I have mentioned the people that I think I wanted to plug you with. There's many others that I cannot remember and not even, try to mention, because we would talk until Jesus comes, There's many. But please make a habit of supporting local guys as much as you can. Support international stuff, but support local first, then international, okay? Don't go international and forget local. Again, guys, now there's two guys which you should not need any introduction to. Lungisi Nkosi is one of the very best and very popular, so you can never miss them. So if you don't know them, it means you don't know the subject, and you definitely are not going to make much of it. There's also Kevin Metz in science. Again, very good, very experienced in the teaching of these subjects, and very popular, if not the most popular in our generation, if I was to think and look. So again, those two don't need an introduction into this. So these are the people that you should already be knowing, but I'm trying to show you the other guys that you need to have a look at, because there's some unique abilities that can actually improve you even a lot faster than the guys who are already up there. You already know, because you already know the approaches, you already know everything. So if you don't get it, you might want to look around these other guys I mentioned to supplement or complement whatever you have learned. Okay guys, let's cut it here. It's too long. I didn't want it to be this long, but it became long. Anyway, we've had a chance to chat as well. I'm not very good at making videos and just chit chat. My train of thought is just too wide and crazy, and it's very fast, by the way. I move from topic to topic without you noticing the connection, and you'll be like, ah, this guy is crazy. He's here and there. But if you pay attention and you're sharp, you will actually see that everything I say is connected. It's just that you missed it. Anyway, guys, all the best for your learning of Maths Paper 2. Please practice and have patience with long videos to build your endurance so that you can maintain concentration for longer. And that means the exam becomes a piece of cake, because if you are used to concentrating for 5 hours and more, it means you can concentrate for 3 hours and still be at your best at the end of those 3 hours. And then of course you just work on your speed in between to try and match your endurance. And therefore you go and get your distinction standard style. Alright guys, goodbye. I'll see you in another video. Bye bye.